code that you can use that is ready to be used. And that's all from my side, and I will leave a few minutes for questions. Thanks a lot.
Thank you very much, sir, for your insightful talk. If there are any inquiries from the participants or the experts present over here, you can ask some questions.
Good morning, one and all present over here. I have a question that how it is related to management decision-making model. For multi-criteria decision-making model is concerned. Because generally we take the primary data, secondary data. How could you suggest?
Yeah, decision making is part of the process of solving a multi-objective problem. But people in computer science normally don't work much on that. It's more common for people in operations research. But when solving a multi-objective optimization problem, there are actually three parts. One part is to build the model. Second part is the optimization of the model. And the third part is the decision-making process. In decision-making, basically, given a set of solutions, which could be very large, the human or whoever is decision maker, could be an algorithm, has to select very few of these solutions based on some preferences. It is possible to design a selection mechanism for a multi-objective evolutionary algorithm that incorporates preferences from the user. There are several proposals in this regard. I didn't mention this in the talk due to time constraints, but it is possible. So in management, most people have done that. They incorporate preferences into the selection mechanism of a multi-objective evolutionary algorithm.
Thank you. Thank you, sir.
You're welcome.
So, Professor, I have a small question.
Sure.
I read somewhere that this single objective optimization is not giving enough scope for the decision makers. So there is a multi-objectivization, right? That means you add some dummy objectives or some other objectives so that it becomes multi-objective function. Now, does it help?
Well, yeah, but the extra objectives don't have to be dummy objectives. You can do it like that, but then you are making up the objectives, right? In practice, normally there are other objectives. It's just these objectives are normally not considered because many people don't know how to solve a multi-objective problem. So it's easier to transform, for example, some of these objectives into constraints, and then you have a constrained single objective optimization problem. But it is true that people have found that if you have multi-objective versions of the problem rather than single objective versions, at least you will find a higher variety of solutions. And this helps in the decision-making process because you have more options to choose from.
Mm-hmm.
So yeah, that is true. Mm-hmm. But you can do it in different ways. Some people have used dummy objectives, but this is normally done for a different purpose. It's not really required because in most problems, the other objectives are there. You just need to look carefully.
Oh, okay. Thank you.
Thank you.
Any more questions? So, thank you, sir. This is Mrutyunjay Panda, the convener of the conference. Wholeheartedly thank you for accepting our invitation to be the chief to deliver a keynote speech today, as well as for your motivation and cooperation and kind support to become a program chair of this conference, also become a editor of the Springer conference proceedings. So with your valuable guidance, we could able to achieve so many things in this conference, sir. Our sincere gratitude to you, sir. And in future, we'd like to see you physically in our campus. With these few words, our sincere gratitude to you, sir. And because it is late night at Mexico, still you could able to give us time, for which again I convey my sincere gratitude from the Utkal University fraternity for your love and affection, sirs. Thank you very much, sir.
Thank you.
Have a nice day, sir.
Thank you. Thank you.
To continue with the talk series, we have now keynote address 6, and the speaker is Dr. Saroj Kumar Meher. Dr. Saroj Kumar Meher is an associate professor in the System Science and Informatics Unit at the Indian Statistical Institute, Bangalore Center. He received a BSc degree in Physics Honours from Sambalpur University in the year 1990. His MSc degree in Physics with Electronics Specialization from NIT Rourkela, and also PhD in Science from NIT Rourkela in 2003. He worked as a senior research scientist at research and development units of various industries in India for about 3 years. He was awarded many times for his excellent contribution to various critical projects. He worked as a postdoctoral fellow and visiting assistant professor at Indian Statistical Institute, Kolkata from 2005 to 6 and 2009 to 10. He received Sir J.C. Bose Memorial Award of the Institute of Electronics and Telecommunication Engineers, India in 2003, and Odisha Young Scientist Award for Research in Electronic Science and Technology in 2003. He is a senior member of IEEE since 2011. His current research interest includes image processing and analysis, including remote sensing imagery, pattern recognition, granular computing, domain adaptation, adversarial machine learning. He has contributed about 80 research papers in well-known international and national journals. He has already chaired many international.
Good morning, everyone. It's a pleasure for me to hear, and thank you, madam, for this generous introduction, and thank you to my dear friend. So when he invited me, I was delighted, not for the conferences, because we are meeting after 20 years. We are roommates, you can say. We used to eat with a single thali and all the things those days. 20 years back, it is 2001, I'm telling. So, thank you. So, I'll not take more than half an hour. So, I'll try to squeeze my talk within that. And if any further discussion or any further queries if you are having, then you can have that one. And I'll be available in this email ID. With this email ID, and you can put a word to me if you are really interested in that particular area for your research and academic areas. The discussion or the presentations here today is semi-supervised learning with spatial informations and granular neural network. Now, yesterday, Professor Ganapati Panda has already given a brief descriptions of what is machine learning, what is pattern recognition, what is feature selection, feature extractions, the basic concepts of all these things. So I'll not go to that part. So I'll directly land in this semi-supervised learning aspect and what is spatial information and what is granular neural network. So first of all, we'll discuss about what is semi-supervised learning. You must be knowing from yesterday, many speakers and many authors have already discussed what do you mean by learning. Okay, so learning comes with adaptation, changing. So we all are learning. You are learning, I am learning. So we are always in a learning stage. The moment we are changing our parameter of learning or changing the parameters of our systems, then we are learning. Okay. So As you all know, there are three basic categories of learning, like supervised, semi-supervised, and unsupervised. Okay. So this fellow comes between supervised and unsupervised. So that we'll discuss and how it works. And basically, there are two broader classification of semi-supervised learning. And then I'll touch a little bit on this granular neural network. I think this terminology maybe is somehow new to some audience. If somebody is already aware of that, that's fine. So it's a new versions of neural network. It's a different version of neural network. Okay, so that are certain advantages of this granular network that I'll touch that one. And one case study I'll also show you. And one particular algorithm which we already published in IEEE, that also I'll talk about. And I'll not talk much. I'll not go to the deep of that one. So if you are interested, you can follow that and you can refer to that publications. So this paper was published in 2020. So it's already 2 years old. Yeah. So why supervised learning? For everything, there must be a motivations, right? Why you are here? Why I am here? I have a motivation, you have a motivation. So what is the motivation behind this semi-supervised learning? When you can go for supervised learning, when we go for unsupervised learning, what is this in-between business is happening here? Okay. Now, as you all know, semi-supervised learning requires large number of data. Not only large number of data, it should be leveled in nature. You're understanding what you mean by leveled data, okay? So supervised learning requires large number of level data. But for what reason it requires large number of level data? Because you need to estimate several parameters of this probability density function, these, that, many parameters are there. So to estimate, whenever you are doing some kind of estimations, right, you require large number, right? So that estimations cannot be done with less number of samples, less number of level data. So that's why we go for large number of data, and when we are having large number of data, you can easily go for supervised learning. There is no need to go for unsupervised or semi-supervised. Now another extreme is unsupervised learning. In unsupervised learning, you don't have a level data, right? And you don't have a level data, but you need to develop a model on top of that. So this is what unsupervised learning. The semi-supervised learning comes in between them. Now, what can be done by the semi-supervised learning? There can be two extremes. Either you are having data or you are not having data. If you are having data, go for supervised. If you don't have it, data means level data. I'm talking about level data. If you are having large number of level data, go for supervised. If you are having large number of unlevel data, go for unsupervised learning. Now, this situations comes when you have less number of level data and more number of unlevel data, which is the real-time scenarios I'm talking about. You talk about medical data, you talk about telecom data, you talk about remote sensing data. Wherever you go, you'll see large amount of data. What about the big data we talk about, right? Big data, most of the data of the big data are unleveled in nature. So we cannot go for supervised learning there. We can go for unsupervised learning, but when you are having partial amount of level data, small amount of level data, why not utilize that one? It is something that I have small informations, so I should use that information to take a decisions instead of ignoring that one. So there is an advantage for that one. Okay. So this is the situation where we go for semi-supervised learning. We have large amount of unlevel data and small amount of level data. So what do? We start learning from small informations or small level data and keep on growing that sample size so that we will ultimately end up with a large number of level data which are extracted from unlevel data sets. So it was seen that logically it makes sense also that semi-supervised learning gives a better result than unsupervised learning, and it also helps you to develop a supervised learning out of small amount of level data, right? So this is what I already do with small number of level data and where we can go for unlevel data, right? Real-time data sets, getting level data is very difficult. As you can understand here, it requires expert to level, it requires cost, boring. I mean, it is scarce and expensive. We have data, but we don't know what is the level of the data, like your big data analysis. Okay. People talk about big data, right? But how to analyze that big data? Big data is more supervised. Okay. Are you aware of what do you mean by big data? Can anyone define what do you mean by big data? Or what is big in big data? I used to ask like this. What is big in big data? How do you define it in big data? Let it be interactive. Can anyone? Okay. So is it the only definition of defining big data? Big. That word big. Big data. Data is big. But what do you mean by big? Don't you think that big is a vague word? It's a vague word, right? Uncertain word. Unclear information. Big means what? This size is big, or this size is big, or this size is big. Which one is big? Somebody talks about some petabyte or terabyte or big data. Is it the big data? So can you define what do you mean by big in big data? Anybody? People many times talk about big data, right? Nowadays. And that they feel pride in telling that, yes, I'm working in big data. What is big in big data? You might not have heard that. This can be also a question. Somebody can ask, what is big in big data? Can it be a question? Does it make sense or not? Am I asking any out of sense things? It makes sense, right? What is big in big data? Anybody, please? Okay, you search the literatures and try to get the answer. What is big data? So anyway, so evidently cheap and free on-level data. Okay. So this is all I already discussed. I'll just keep that one. So this comes between supervised and unsupervised. That is called semi-supervised. This is the motivations. I'll come up with a kind of comparisons here, labeled and some examples. Okay. So I'll also skip that one. I'll just directly go to the example. Just try to understand how semi-supervised learning. Semi-supervised learning helps us to get a better decision. See, there are two categories of classes. M stands for men, F for female, male and female. Okay. So there are two samples of males and one samples of female. Very few. You need to develop a model for that. Practically, is it feasible? Starting with two samples of one class and one samples from another class. Is it practically feasible to develop a model out of these things? As I already discussed, right? If you want to go for supervised model, you need large amount of level data. Okay. So that you don't have. But we have abundant amount of on-level data. You can directly go for clustering or you can go for unsupervised learning. That's fine. But we don't want to go to that side. When we have small informations, why not utilize that? Try to utilize whatever is there within you. Then you will think about what is not there with you. Okay. So just see. This is one on-level data. This is leveled. So slowly, it is how it is gaining the information sets. See. So on on-level data, U means on-level. Okay. So U1, yeah, this is the data set and this is what models. You got this point, no? U means on-level and this is leveled. Okay. So my query comes here and asking whether this is a male or female. I have only one samples of female, two samples of male. Model is like this. And what is the decision C? U1, U2, U3, U4s are on-level data. U means on-level. F goes for female, M goes for male. Okay. So slowly, how it is happening, see. When this samples is coming, U1, this first on-level samples are coming. So this on-level samples, how it is, in what way it is similar to these three samples? Just have a look on that one. It is very much similar to this one, right? Neither this one nor this one. So what you are telling, you are getting some kind of confidence level. You are not sure about that exactly this belongs to female, but you have some intuition that this may be a category of female. So utilize that information, whatever information you gain, okay, and then you put it in female category. Like that, you keep on giving these things, and finally you can say that this samples belongs to which category. Okay, so this is one example, just to. Then I'll skip these things. As I already told, combine the level and on-level samples during training to improve the performance. So, no, we don't do that. There are semi-supervised classification and clusterings also. Let us not go to that part. And there are some other algorithms are that also I am just keeping. I'm just coming to that exact things or algorithm where we can discuss more on that. So I'm just keeping these things. So this is what is workflow of a semi-supervised learning. Okay. Just see, use both level and on-level data. Input X, every input has one level, right? So develop a classifier and put that level on that data. So this is what you are having plenty number on-level data, and you keep on giving that confidence level to the on-level data and keep on adding to that level set. So slowly what you are doing, you are increasing the level information in your level data. And the moment you are end up with a large number of level data, then you go for, or then you tune that supervised learning or supervised model. So this is what the semi-supervised learning is all about. So there are two kind of broadly, self-learning or self-training and co-training. So these are the tutors that also I'll just keep. I'll share this slide if you are really interested, then you can have a look on that one, because I have to finish that one within half an hour. Okay. So I'll skip this. Advantage and disadvantage of semi-supervised. I hope you are understanding now what is the meaning of semi-supervised learning. Okay. So advantage and disadvantages of the semi-supervised learning is very simple, applies to all existing classifiers. You can have any model and you apply that for semi-supervised learning. Okay. Disadvantage is that mistakenly strengthen themselves. What will happen is that, see, actually what you are doing, you are level set on level set. You develop a model using the level set. Once that model is developed, you try to apply or assign the class level to on level data sets. Let us say 1 or 5 samples are there. You pick 5 samples and try to level them. Out of them, whichever is having better confidence. Do you understand what is the meaning of better confidence in the classification? You are taking a decisions. That is your classifications. Then what is the confidence level in that classifications? That matters a lot in machine learning. It is not only the decision, you should also have confidence level. It is something to say that if I'm asking a questions and you are answering that, yes or no, let us say binary decisions. Now the next level of questions is whether you tell yes or no. It's your decisions. But what is the level of confidence on that decisions? Many people say, right, you might have realized or you might have seen many times in our human society, bluntly, with full confidence, people say negative thing and we all accept it. Does it happen or not? Even if you are telling wrong thing, put it in with full confidence. People will start accepting that. Does it happen or not? It happens. So that is what the confidence level. So that confidence level you can get in the classification decisions also. Are you understanding how to do that? Confidence level means your decision-making process, how much probability of the confidence you are having in that decisions. For example, let us say I'm talking about that confidence level to give you a better understanding about that confidence. You know, any classifier we can take, like Bayes classifier or neural network or KNN or minimum distance, anything. Okay. Let us say neural network. You all are aware of that. In the output of the you all are aware of neural network. Right? Shall I go for a? Okay. Let me go to the easiest one, minimum distance classification. You know that? Okay. So you find out the centroid and find out the distance, and that gives you the model. Minimum distance. Let us say there are 2 samples. So the 2 samples is having distance from that mean is, let us say, one is 0.5, another one is 0.7. Okay, and rest of the samples are having more than that. So minimum distance means whichever is distance having less, you assign that class to. I hope you are understanding that one. Minimum distance classification. Okay. Now, one sample is having 0.5, another sample is having 0.7. Now, tell me, for which samples you have more confidence? You got my point? In minimum distance, first of all, you let me know whether you understood the minimum distance classification or not. You know that? Okay. Minimum distance, what do you do? The samples which has minimum distance from the centroid, you assign that class level there. One sample is having 0.5, another sample is having 0.6. So which sample has better confidence? I mean, the classifier has better confidence on which sample? 0.5 rather than 0.6. This is what the confidence level. Let us say I'm having another sample which distance is 0.2. So that is more confidence than the other one. This is how you can, I'm just giving one simple example. How do you calculate the confidence level? This is what the confidence is all about. In neural network also, you output side, you are getting the output between 0 to 1, right? So you are, what you are doing, you are putting a threshold, and beyond that, this class, beyond less than that, this class. So whichever is having more towards that, then you can put your confidence level. Like that, that not is redundant. So many things are there. So real-time data are like this, and we are going to develop your model on those kind of data. So let us say I'm having a data set which is not correct. That may happen. Not correct, but your model doesn't know that whether it's correct or not. So what is happening? That model is by mistakenly putting more confidence on that wrong samples. Okay. So what will happen? Because it is giving more confidence, that wrong samples is getting classified in a wrong way. But you will never realize that one. It will be added to your model or data set. So from data set n to now your data set numbers becomes n plus 1. So you will assume that wrong classified output as your reliable source of information. What will happen finally? The next level of classification, whenever you will do, this will have a repercussion. Consequences will be there, no? The moment you start committing a mistake, the moment you did some mistake, to cover up that mistake, you do another mistake. That is what we do. We are all human. This is what human psychology. So this way, wrong to wrong, wrong to wrong, wrong to, it will be a cumulative effect, and finally you will end up with a wrong model. So that is what is happening here. Mistakenly strengthen themselves. Model will be thinking that I am strengthening myself, but actually it is not strengthening. Okay. So this is what. I'll just skip that one. I'll come to an algorithm actually, which we developed. I clicked wrongly. A new variant of self-learning semi-supervised model. Okay. Your generic semi-supervised learning model flowchart will look like this. This is what your generic semi-supervised model. Okay. So you are having available level data, you give a training, assumed, self-supervised learning, then test them, classify them, as usual. So this is the proposed one. Recently, as I told you, 2020, we proposed this algorithm and it was published in an IEEE paper. So you can refer to that one. So available data and all the things are there. So what we are doing here is that we are finding out some similarity matrix. That means, see, you might have realized by this time that the moment you are picking a samples from the on-level data set, you should have better confidence on that one. So how to get that better confidence in a correct way? That is where everything comes. If you don't do that one honestly, the further processings will be in a wrong side. So that is where that catch point is there. The moment you are picking a wrong samples means you are gone. So you should be very much careful. So this logic is based on that particular small component only. we are trying to improve the confidence level in a correct way while picking the samples from on-level data. Okay. So this is what we are doing here. We are generating some similarity matrix. I believe you are understanding. Available level data, training samples, the training set is there, and assumptions. We are assuming some kind of, in this process, the earlier thing was like this. There was no such in-between processing. So here we are doing some kind of processing here. So what we are doing, we are trying to gain more confidence while picking the samples from on-level data. So what we are doing is that we are generating some similarity matrix on the on-level data. What is the similarity matrix is? It looks like, let's say I'm having 8 number of on-level samples. So similarity matrix 1 is telling that how many neighbors are there to each sample. Neighboring samples. How do I understand the neighboring? Whether I am neighbor to someone else, I'll find some equivalent distance. Okay. So within that equivalent distance, within this range, how many samples are there that I'll calculate? Let us say I am having 8 neighboring samples. So I'll say that this fellow belongs to or neighbor to me. So that way, it's a very simple logic. We try to gather the similarity matrix. Whether U1 is a neighbor to U1, sorry, U2, U3, U4 or not. That means which neighbor to whom, this matrix will give you. 0 means not neighbor, 1 means neighbor. So how do we calculate here? We calculated just by a simple metric, that is your distance metric. Okay. It's a simple distance measurement. You can go for any other similarity matrix. So like that, see, earlier work, what it was doing is that, actually it is an improvement to earlier work. Earlier work, what it was doing, let us say there are 2 samples, X1 and X2. So that work was related to something like this. If X1 is near to X2, then I will say X2 is neighbor to X1. That means one way of calculations you are doing. That means whether I am neighbor to you or not. But is it always necessary that if I am neighbor to you, you are also neighbor to me? Try to think about that. There are 2 samples, X1 and X2. X1 is neighbor to X2. Is it always necessary that X2 is also neighbor to X1? Not necessary. Try to think about that. And the whole paper is based on this concept only. You got my point? 2 samples, both way we are trying to find out whether they are neighbor to each other or not. If anyone is failed, then we say they are not neighbors. So earlier work was on one side and our work on mutual side, both these sides. Okay. Not neighbor to. So what we are doing is that, let us say, for neighboring scenarios, what I am finding out the distance and number of samples within that range. Correct? Let us say I am taking 5 samples. Now what I will do, I will X1 minus X2. It's simple. So within that way, I will find out whether that one is a part of that 5 samples or not. 5 samples are there. Now when I am finding out X2 to X1, instead of X1 minus X2, X2 to X1, then what I will do is that not only X2 to X1, I'll also find out its own neighborhood X2. Now, not necessary that X2 will contain that 5 samples, which is X1 is also a part of that process. Distance will be same. Distance will be same, but the moment, because that number I'm calculating now, 5, 6 numbers. So this may be neighbor to X1, but X1 may not be neighbor to. I'm only considering neighbors when 5 samples are within this range or 8 samples are within the range. Now, when I'm calculating the other way, maybe this samples is not a part of that 5 samples which I am considering as the neighbors. Whereas if I calculating this way, that fellow is coming here. So that situation is coming. So on that basis, we try to improve these algorithms, neighboring concepts. Okay. So there are Other 4 ways of finding out the neighbors, here we have proposed 5 similarity metrics we calculated, and we try to improve the performance by that logic. Okay. Now another component is coming, granular neural network. Okay. How much time is left, sir? I can go for lunch till lunch also. Oh, sir is there. Oh, he will kill me then. Okay. Sure. So another component, as I was telling from the beginning title, right? Granular neural network. It's a new variant. It's not a new variant. A variant was there which people were never looked on that, and all of a sudden it came to the limelight and people started working on that one. This granular concept actually came in the 1965, from the day when fuzzy set theory was conceived. 1965 it was coming. It came, the fuzzy set theory. So the granular concept is actually based on the fuzzy set theory and rough set theory. Okay, because this uncertainty and all the things are there. So what we did is that this granular concept is incorporated to the neural network, and the whole concept becomes granular neural network. And the motivation behind this is, there are many limitations of neural networks. Let us not talk about the advantage of neural networks. Let us talk about the limitations or disadvantage of neural network. What is the limitations or disadvantage of neural network? Can anyone tell at least one? The biggest disadvantage is that it acts as a black box model. You are understanding the meaning of black box model? What is happening inside that? No one can estimate that one. It's happening. People say neural network is something like playing with a dumb. Dumb means who cannot hear and who cannot speak. But it works. Neural network is working, yes or no? It's working. But can you say why it is working? Can you give me a proper explanation why it is working? On what basis it is working? Because it starts with a random play. You take a random samples and you start with that random playing. Now, random playing may not favor you, may favor you also. If you are lucky, see, you are understanding, no? Sometimes I am getting the result with 100 iterations. Sometimes I am getting the results with 200 iterations. Sometimes 500 iterations. If I am changing the parameter, my number of iterations is going higher or coming. Everything is a random play. You are throwing a stone in the dark. It may hit, it may not hit. But most of the time, it hits. So it's a black box phenomenon. So what this granular component is doing here is that it is trying to open up that processing steps of neural network. It's trying to make it little bit transparent. Transparent means you are able to visualize actually what is happening there. It is not the complete visualizations, but to some extent it is giving you better visualizations. Before the granular network, you might have learned about or you might have heard about neuro-fuzzy network. You heard about the neuro-fuzzy network? Neural network and fuzzy set theories are merged and they became neuro-fuzzy. It's a hybridization technique. You know what is the advantage of hybridization technique? Hybrids. Everything has become a hybrid. Now, tomato became a hybrid, then normal tomato, hybrid tomato. Normal mango, hybrid mango. Everything. Now the situation is, most of the time we enjoy hybrid things. You remember, I'll give one example. So when in our days, school days, standard 2 or 3, in our village and all the things, only summertime we are getting mango. Mango, you are understanding? And that tree was so high that we are struggling 2-3 hours to get a small mango while going to take a bath in a river or pond. I think you all might have experienced that one. But now what is happening? A small thing can go and pluck a mango within this height. Small big mango. Throughout the year you will get. What is this happening? Here are hybridations, right? So that means we are getting the advantage. We are getting the advantage of the hybridization. That means there are two methods. None of the methods are ideal methods. That you know, right? No one is perfect. Do we perfect? Am I perfect? Are you perfect? No one is perfect. Otherwise, would have become God. We are not God. We are human being. That's why we say, to err is human. So we can commit mistakes. Okay. So there are two models are there. This model is having advantage, disadvantage. This model is having advantage, disadvantage. What will do? Take the advantage of here, leaving behind the disadvantage. Take the advantage of here, leaving the disadvantage. Merge them. Hybridize them. So people did that for what reason? To get a better performance. That you are the ultimate goal. Okay, but obviously your computational complexity will increase. But who bothers for the computational complexity nowadays? Do you really bother about computational complexity? No one bothers. I remember one simple examples. When I was doing my PhD, we used to work in a 186, 286 in 1997. I'm talking about. Those days we were developing algorithm and putting that algorithm in that desktop. And we knew that this output would have never come within 1 or 2 hours. So next day morning, we used to get the result. We are happy with that also. But if I bring that algorithm now in this computer today generations, within a fraction of second, it will give me the result. So why shall I bother about the computational complexity? So what should I bother here now? Performance. Results. Okay. I understand, sir. I understand. Yes. But to our level, that is more than sufficient. You remember, I was using a desktop which hard disk was, I think, some MB hard disk capacity. But forget about the memory. Now I am using, my institute has given me a desktop whose memory is 68 GB. Sometimes I feel what for I am using that one for email and writing, this searching and writing some documents and all things. I am using 68 GB RAM. You are understanding 65 GB. So we, our elder generations like SARS, they might have experienced some different experiences. So anyway, so this is what the concept of the granular and neural network. Neural network, to make it a little bit transparent, we came up with a neurophogy network. Hybridizations, but at the same time, it is giving you a more transparent vision towards the model. Okay. So this is what neural network we all know. Neurophagy, what they do is that before sending the input, they phagify that. I believe yesterday Professor Panda might have talked about fuzzy theory and to some extent. So it is something like dealing with uncertainty. We are not perfect. If we say 10 o'clock, our meeting will start. Do we start at 10 o'clock? We start, plus minus kind of thing. So this is what the decisions. Yesterday, one speaker was, I think Professor Panda or somebody was telling, our decision is soft in nature. This is what the meaning of softness. Can you take a hard decision? Can I take a hard decision? No, at 10 o'clock only our meeting will start. Who cares for that 10 o'clock? So this is what is happening. But we are happy with that. Are you not happy with that? Flexibility. Flexibility makes us happy, right? So more flexibility, more freedom, more enjoyment. But to certain extent, it is acceptable. Okay. So this input layer, before sending the data, what we do is that we fuzify them using first set theory. We do some kind of rough set theory processing. Let me not go to that where this processing is done. So by doing that one, we are actually opening that information space of the input data. Many times it happens, you might have also realized, if you have already worked on that pattern recognition and machine learning, information is there, but neither you are able to understand, nor your model is understanding. Are you getting my point? Information is there, you are not able to understand that information. Now, if you are not able to understand the information, how can you develop a model? Even it talks to you as a human way of taking decisions. Let us say I am giving one problem to you. So you are solving that problem. Now, what will be your first step of processing? Try to understand the problem, or closely or with your blind eyes, without understanding, you start solving the problem. You don't do that. You try to solve the problem. So the first step is to understand that problem. To understand that problem, you need to understand the input informations, input data, input task. Now, who will help me to understand that one? Because it is not clearly visible to me. It's not that I am blind. I'm not blind, but to my eyesight, to my understanding level, this information is not understandable to me. And the moment I am not able to understand the input informations, I cannot develop a good model. So when can you give a good solution? The person who can understand the problem in a better way. Do you agree with me or not? So that is what we do here. Fuzzification and offset theory we do, and that process is called granular processing. Or we call it the granular component. It's a term which was there earlier, but people started using this term in the recent decades, last decade. Okay. So it's a kind of abstractions concept. This granular computing is a kind of abstraction concept. You know, you understand the meaning of abstraction? Abstraction means summarizations. The more the abstractions ability you are having, the better understanding about the model and better understanding about the, or better you can solution you can provide. Okay. So for example, one example I am trying to give how to meaning of granular computing. So what it is doing is that, let us say I am traveling to someone. Let us say when I came to Bangalore, I would have asked my friend, hey, tell me what is the weather conditions there, whether it's hot or cold or something like that. So what my friend did that, no, little bit sun is there, some cloudy is there, and weather is not so chilled. Try to understand the scenario. What question I asked? What is the weather? And what answer I got? It is little bit cloudy. What do you mean by little bit cloudy? Does it have any meaning? Quantify the statement. It is little bit cloudy. Can you quantify that statement? First of all, you cannot quantify what is the meaning of cloudy. Cloudy means what? Less cloud or more cloud? And if I say it is a less cloud, what is the quantity? Less means what? This much cloud or this much cloud or this much cloud? Try to understand this scenario. This is what the uncertainty level. When we are answering that one, we are putting so much of uncertainty into our answers. So when that kind of situations comes, but still I am happy. When my friend told it's little bit cloudy, I understood. But let us say I am not happy with that decisions. So what I'll ask, no, it's little bit cloudy. Tell me what is the temperature during daytime? Now my friend told it's around 25 degree during daytime. And I'm happy with that one. But is it an answer? What is the meaning of around 25 degree? You tell either 25 or not 25. What is the meaning of around 25? This side around or that side around? Which one? Try to understand. This is what the logic of abstraction. So he abstracted that information, summarized it, presented it, and I am also as a required person, I understood that. Now let us say I am not still happy. Don't say this around, go and take a thermometer and tell me exactly at 12 o'clock what is the temperature. No, it is 23 degrees centigrade or 23.5 degrees centigrade at 10 o'clock or 12 o'clock. This is what the exact information. Now in these three examples, what did you learn? First one is the abstract level information. Second one is the little bit more detailed information. Third one is the exact information. Now, when I am not asking the detailed answer, why you want to give me the detailed answer? First question was not detailed questions. Did I ask you what is the exact temperature? No, I asked what is the weather condition. When my question is an abstract one, why do you require a detailed answer for that? The meaning here is that when there is no requirement, why you are struggling? When I don't require the exact information, why you are giving? Because giving exact information, you have to spend your time and money. That is why the computational complexity. And that is the concept of granular computing. In a hierarchical way, you check what is the requirement, what is the detail level information somebody is asking, and accordingly you provide the answers. Okay. Now I think I crossed the limit. Anyway. Small example of granular computing, I think, because we all are researchers here, so I'm just telling. When you write a paper, have you ever written paper, right? When you write a paper, what do you sit? So what do? You do the literature survey and all the things. When you do the literature survey, and when you look for the technical writings, so what first impressions you get from this paper? That means from which point you get the first impression about the paper? From the title? From the title. First you check the title. Okay. Now, when you check the title, you will have a summarized information about that paper. If you are really interested, then go to the little bit deeper. What is the next level of detailed information? Abstract. Abstract is the next level of detailed information. Then your title. If you are still trying to understand the more detail, then you go to the introduction. So like that, these are the hierarchical informations you are having. At what point you want to take decision, you go to that point. Why you are from the beginning itself? Do you take the decision by reading the whole paper or just by seeing the title and abstract? This is what the granular concept is all about. Okay. Anyway, so we applied that one with remote sensing analysis, and so these are the equations which helps us to update the algorithm. So I'm not going to the detail. So I'm leaving that one. So the conclusion is something like this. I think I have already concluded or given the description of whatever it is done. So it was done something like the unsupervised learning and supervised learning in between scenarios. It gives you a kind of feel that you can also develop with minimum number of samples. Okay. Here we have used the classification model as granular computing or granular computing based model, which helps us to understand the model in a better way. Better way means transparency of these processing steps are understood properly. And in combining all these concepts, we improved our performance of the model. So this is what the conclusion. So I'll stop here. Please, any questions? And if I know that answer, I will be happy to answer. I'm also a learner. Let me first tell you from the beginning.
I have few doubts. The granular neural network. From the training phase, the level sample, you fuzify and then train it. And when you do the testing, at that time also you fuzify or no? There also the same technique you use to fuzify, right?
Okay, I'll just go back to the basics. So you talked about the confidence factor. Now, I think that was a game between the right kind of data and you learn the right thing, and the wrong data. There's a possibility that you also learn the right thing. So that was the thing. Now, see so now the thing is, I mean, the kind of example that you gave, unless there is a human intervention, why the system will learn a wrong thing from wrong data? Because the system should know that, yes, this is wrong. Because the system is learning after several iterations, the system is trying to distinguish between what is right and what is wrong. How can the system attach a confidence factor when it's learning? A human being can mislead somebody, but how the model can mislead? So that was the question. Yeah.
So these things function that we have level data, we have non-level data. The level data we have the model. That model we have on level. But that I will type on level. So I'll put the class level on the non-level data. Using the develop model to get developed level data. Now let's say 25 samples I got. I don't have the class root of the non-level data. I don't have the exact potential class level of the non-level data. So I just get the estimated out. Out of the estimated out, that is having 4 multiples. Then I can understand that how I look at that. Now, I saw that 2 samples level to class non-level. Out of the 3 samples, 2 samples having 4 confidence, 1 class. Then I look at this. Now, that you ask wrong things, whether it's being wrong things. Now, our data are not. We get level data, but who is preparing the data? After what? State is prepared once. But we understood that the issue that the data are level to the next one. Model and give one
Okay, thank you. Sir, I beg to interrupt here, sir.
Interrupt.
As we are running late, so I request Meher sir and sirs to discuss at up time.
A big round of applause. Thank you, Dr. Meher, for a very elaborative discussion. And now I'll request convener sir to present. Sir, we have a memento ceremony. Yes, sir. Convener is showing more love. So continue with the. It off over, yes. खोलता उससे बैग बोले दे दे. See, office room में. So we'll continue with the talk series. Next, we'll have our keynote 7. Technical interrupts. 2020. He was part of the GATE 2020 organizing team as vice chairman when IIT Delhi was the organizing institute. He was also chairman of GATE Jam 2021 IIT Delhi. His area of interest is graph theory, algorithmic graph theory, computational optimization, parallel computing, and algorithms. In his professional activities, he has been program chair and co-chair in different international conferences in 2017-18 and prior to that also. So now it's time to hear from Professor Dr. B.S. Panda, IIT Delhi. The title of his talk is Emerging Topics in Wireless and Network Communications, a Standards Perspective. Over to you, sir, please.
Okay. Thank you for the kind introduction, but the title is not correct. I think it is wrongly typed there. So I'll be talking about influence maximization. As you have seen that I work in majorly algorithm, that means hard computing. But now, if you see this data sets that you see, maybe around 50% of the data sets are having some kind of relationship. So that means those are graph data, like any complex network, Facebook and other things. So you'll find a lot of data sets are based on graphs. So the traditional machine learning, if you apply like neural network and other things, deep learning, so you cannot directly fit into this thing because you have to get a new representation in Rn and then only you can apply. So you cannot directly apply. So over the year, neural network have been designed like graph neural network, graph LSTM and many other things. So since I'm working in this thing, so I'm a maybe learner, maybe last 4 or 5 years I have started working on this one. So I'll talk about one problem. So it is a hard computing part as well as soft computing part because of your data sets are very, very large. So it's a good way to the beginners to learn also how to use machine learning on a new problem, right? So some of the data sets, some of the problems, definitely now in the first instance only you'll find that you can use machine learning. But other data sets, if you can say that machine learning can be used, that is the major contribution. Then a lot of papers will follow. For example, you see, computer vision is a hard computing part. So a lot of segmentation and other things are there. And now because of this development in the machine learning and now supercomputers are there, a lot of computing power is available. Now, today, if you see the computer vision, it is nothing but machine learning. No hard computing part is now almost saturated. Now people now comparing and then now predicting because your data set is very large. For example, in the traffic, somebody is going and number plate is not visible. So you have to do all segmentation and other things to clear the image and see what is the number plate and you give the channel to that particular person. Nowadays, you have big data sets and you just compare and classify what is that number and other thing and directly you do it. And sometimes, you get the wrong channel and so you have to prove that. Daily it happens. A lot of cameras are there, they take. So I have very, short time because there is another schedule. Few things I expect you to learn, at least what is the problem statement, how to do this thing, and then how to model as a problem for machine learning. So the influence maximization is there. For example, you have, maybe I'll just see, the complex networks, you will find a lot of networks like internet, biological network, email network, collaboration networks, social networks. These are complex networks. They exhibit certain properties. The degree distribution, so these are basically graphs. So degrees, they follow some power law distribution and another is scale free. So these are the two properties a network satisfies. Then these are called complex networks. Number of nodes is very large. And there is one problem, I just skip it. Influence maximization means now given a big network, you have to find a subset of nodes. And in those nodes, if you put some information, So information in one step, a node can send information to its neighbor. So what is the minimum number of steps where all nodes will be infected or getting the information? So this is the question. So how to choose a subset of nodes? Those are called spreaders. And once they have information, now it will spread to everything, all the nodes. So this is basically, applications are huge, like viral marketing. Suppose a company comes up with some product. So these are the users they will choose, and this is the incentive they will give. And these users now will spread the information, so quickly everybody will know. For example, a new iPhone comes, so you'll know, you will tell to your friends will tell to others. So this is how it spreads, and then the product become popular. So given a complex networks, information propagation model N, but in hard computing, a node can send with one probability 1 to its neighbor, but it doesn't happen. Suppose you have 10 friends, even if you send, you may forget to send somebody, with some probability you will send it. So there is a diffusion model, information diffusion model, that is another kind of research. I'll see what is this thing. So once a propagation model is there and a positive number k is given, the objective is to find a subset of nodes, these are the seed nodes, so that the information spread is maximized. So for any other sets, so the information of this will be less than equal to this. Information spread means the fraction of node which will get the information after some amount of steps, right? So viral marketing is most popular application of this particular problem, influence maximization, due to its commercial value, where a company desires to promote a product from few initially selected influential users through word of mouth strategy. So this is one application, and you'll find, so maybe thousands of papers have come on these particular things. Some are on the hardcore domain, some are now machine learning based domain as well. So for example, some of the application of this field is controlling rumor, confining outbreak of disease, opinion maximization, political campaigning, social recommendation, etc. So a lot of other applications are also there. So if you see, as I told you, thousands of papers have come in this single area, maybe another last 10 years or so. So every year you find several papers, and they are classified into these following categories. Node centrality, this is basically who can be the spreader. The node which has a maximum degree, then intuitively that happens, that you have more friends, this person is chosen as the spreader. But what will happen, two nodes are close by, its degree also high, its degree also high. But after the degree is high, after that they do not have friends, it gets stopped. So this intuitively okay, but it doesn't work well. So this, you find some node centrality and choose the top k nodes with high rank. Of course, this also used as the basic step for many other machine learning algorithms where you require node ranking of the node. After that, you apply the machine learning. There is greedy approach, hybrid methods, community structure. For example, you divide the whole network into different community, and each community you choose some spreader, so that every community will be spread very quickly. So this is community structure based. And the current one is the deep learning and neural embedding, network embedding based method. This is the machine learning methods. So we'll see, initially if you see, it doesn't look like that you can apply machine learning. And now we'll see how it can be done. So that is one part you can learn. So, and that is the major contribution. If you are for new problem, you are the first person who can now recognize that thing, then your paper will be cited like anything. And it will. So for example, so there are a lot of papers, like these are some typical important papers like vote-based, voting-based method, level propagation method, weighted vote-based method, and community structure-based method. And you see the kind of journals they are published. So these are some of the papers where graph convolution network-based approach. This is a machine learning approach in only to 2020, only 19 and 20. Only that is the starting point where machine learning was used for this particular problem. So, so this, once you select the node spreader, how the information goes. So there is a information diffusion theory, they are a bigger one, but there are two well-known model which is being used. This is called SIR model or IC model, susceptible, infected, recovered model. So once you have, during the simulation, how the information is going or how many nodes are getting the information. So you have to, once you get the spreader, after that you apply the diffusion model, and then only you can calculate during the simulation. So I'll talk about quickly 1-2 models. This is the model. So initially this is susceptible, means it is not infected, and the spreader are basically the infected one. So they can infect whom? Only their neighbors. So this is a susceptible node, and with probability beta, you can infect a neighbor, and after some time, this infected node, after that we know it will become recovered. After that, they don't bother. For example, if you are my friend, I'll send information to some of them, not everybody. And after sometimes you become infected, means you have the information, but after 10 days, you forget about that information because that information is not lost. That means you have recovered. After that, you are not going to send this thing. And once I have sent once, I'm not going to send again and again. So I'm recovered. So this is the way the disease and other thing also, like COVID-19, do you know? This spreads like this thing. So if you are in contact, it spreads this thing. And once you are recovered, possibly you are immune to this disease. So this is one, but this beta and gamma that have to now choose. And another model is independent cascade model. So the process starts with some active nodes called the seed nodes. An active node tries to activate its adjacent inactive nodes independently with probability PUV at any time. The model assumes a user B is activated by each neighbor U independently with influence probability this, and the active node gets only one attempt to activate its neighbor. Activate means they get the message. So finally, at maybe 10, after a certain amount of time, how many people are getting infected that you calculate, it can spread to many people, then this is a good spreaders. So that is basically which is the objective. And what are the metrics which are there to a method? Now, infected scale. After T time, what is the fraction of nodes which are getting the message? It is more, then it is better. Second is final infected scale influence spread, FTC, versus K. K is the size of the spreader. If you take only one, it will definitely go less. So what is the K versus this FTC that you have to plot, and so whether your method is good or not. And FTC versus beta, the infected probability. So with what probability, if you do it, then it spreads properly. Average distance between spreader. That means two spreaders are chosen so that they are close apart. There's a spreading capability. One can do the job of the other. So the distance, this one, LS, average distance between spreaders should be maximized more, that they are spread in different regions. Kendall tau value is another important parameter, and time complexity is another parameter. So these are the 5 parameters that you need to evaluate. Okay. One can see the slides will be available, and yes. Yes.
The idea is you're trying to maximize the influence.
Yes.
So what you explain is how you try to reach out to the maximum number of nodes around you, because you want to propagate the information.
Yeah, whole network, yes.
So in that case, you assume that once somebody receives the information, that node is influenced. But that cannot be the case. I may get the information,
Okay.
but I not get my decision is not influenced by the
No, influence mismatch. No. Once you get the information, after that you know about the product. Purchasing the product or not, I don't know. But if you do not get the information, you do not know about the product. So that is how to pass the information to maximum number of people.
So that's why I'm asking why the word influence makes sense.
Okay.
Because I will use the word influence only when my decision making is influenced by influence.
So generally, if you see the scenario, suppose if I tell to my friends, and if I'm purchasing something, they are getting influenced that, okay, tempted. This is a social scenario. That is the reason why it is being used. Otherwise, concrete sense, it is basically information should reach to that. Yes. Okay. I don't know how much time I have. Okay, no, there is another talk, I think. Okay, so average distance, and these are the time we have to see. See, for example, one of the method which was used was popular use. Basically, you want to have spreaders, so you divide the nodes into different cells. So the node which are in periphery or degree, say 1 or less, you put them, you first. You put them in the outer one. After that, you remove it. Then less number of degrees are there. Then you put in the second level. Then remove it, and then you go to the next level. So in this case, k is equal to 1, 2, 3. 3 levels are there. So which one should be the spreader? The spreader should be in this level, the deeper level. So they can reach out to many people. So this is K-cell was very popular algorithm. After that, neighborhood coordinates, another technique came up. Okay, neighborhood coordinates is that not only that, what is the capability of spreading capability of your neighbor friends? So this is basically you have more neighbors, but they are now degree is 1. They do not have many friends, so they cannot, that information will not go. So take the K-cell of all of neighbor, so that is equal to neighborhood coordinates. Then they use vote rank, this thing. So now everybody has some voting right, and this VA is the coordinates value. So based on that only you can now spread the information. And once you have sent the information, after that it is 0. You cannot spread again and again. So then weighted vote rank, because how good your friendship is, what is the strength of your friendship. So weighted thing was there, and 2019 the new paper came, and after that we worked on something called an NC vote rank approach, right? So what he did is the following, that, okay. Okay, so each node is associated with a tuple, NC vote rank, and voting ability means the vote that V will give to its neighbor. So if your strength is high, then you only can give the vote. And voting score, which is obtained from its adjacent neighbors, can be computed by adding their voting ability. So this is basically VA, summation I belongs to neighborhood of V. So you have two components, SB and VA, and so what you do is the initialize it to 0, 1. So SB is equal to 0 and your ability is 1, and voting score of each node is 0, and its voting ability is 1. In one step, voting phase based on the notion that a node is the core of the network can greatly affect information diffusion. So this SB is equal to, we calculate like this thing. So there is a rule. I don't have time. I'll just show you some maybe methods. Okay. Let me see this thing. Okay. What you update phase is that the information in the network spreader should be picked from diverse positions. So we assume that when a node is selected as a spreader, it can influence its neighbor up to 2 hops. For example, I go to a neighbor, and neighbor to neighbor, I can now send the information. So when D is equal to 1 and 2, it captures the second neighbor. But okay. So once you have spent it, what is the? Can you go back? Next, maybe. This one is not working. Just take this thing. Okay. So this is basically, there is no machine learning till this point of time. So this is the algorithm, and it works better than the existing algorithm. That is how we get into this social network or influence maximization. But now I ask you a point, that suppose you want to use machine learning, so how do you go about doing it? So you have to select certain nodes. What kind of machine learning applications you have in mind for this? Is it classification, regression, any other thing? So if you see this one, there is no clue how to use machine learning. Because it's a different problem. You have to find a subset of nodes. Suppose if you have a level data, so what will be the level data? You should have some influence capability of each node in a network. That should be the level data. And then you have to have a model. So what you use, if you this kind of thing network, so there is a probabilistic model, Barabasi model, which now, first of all, the network should be a complex network. That means it should have the scale field property, power law distribution of the nodes. If these two things will be there. And Barabasi network, there is a model which if you can generate such a network, which will be a complex network. This is the first thing. So once you generate the complex network, now you can use any of the, that is working? Slides is working? Okay. Okay. So if you see this one, for example, the square network, the previous method if you use, after one iteration, this is the value. After second iteration, this is what particular value. So if you go for k iteration and then see how many nodes have been infected and you plot it, I'll show you some result. We just go next. Okay. So the result have been analyzed to the current this best algorithm, and it was found that it is basically performing better than this. And the paper got published in 2020 in a journal called Physica A. So after that, just go. Okay. So these are the data sets which are available. Amazon, PGP, Facebook, Dolphin, Enron Bell, Internet, ConMed, Jazz Music. These are the lot of benchmark graph data sets are there. So if you want to do research, first of all, you have to download all these benchmark data sets so that for your experiment now you can use. You can see the number of nodes, number of edges to be very high. Go next. Okay. You just go and then show the results. Okay. Next. Okay. So these are the results. The top one, the blue line, is basically the infected scale among all these things. So if you can see that, okay, this is quite better than the other one. Next one. Next. So the final infected scale, these are, I told you, 5 parameters. You have to plot and then see that, okay, your algorithm is performing well on all those parameters with the current state of the art algorithm on benchmark data sets, basically, where other people have also compared their results. You just go. Okay. Kendall Tower also, if you see this, most of the cases we have the improvement, but some cases no. Please. Okay. So this is the average path distance. Is basically they are spread into different part of the network. The last row, if you see, last column, if you see, all these parameters now you are getting a better parameters. Okay, please. Okay, so this is where the paper got published, but you just, okay. So this is what I am talking about, the machine learning thing. And this is very recent one, 2023, February got published. So in fact, published, I think about 23 it is coming in this thing. So graph LSTM, so you have got LSTM is there is a concept called graph LSTM. So this neural network, what happens, you have a vector then as the input, then only you can go. But once you have a graph is given as a input. There is training set, means for some graphs, you know what is the spreaders. But for other graphs, graph is there, then how you are going to, sometimes you get a smaller graph, sometimes a bigger graph. So neural network, you cannot feed it. That is the problem on graph data. That's why people have come up with something called graph neural network, graph LSTM and other versions. right? So, but now to see this as a problem of machine learning, that is the first stage. So just you do one thing. Okay, next, you just go. Okay, first of all, you have to extract the feature, and then level generation, you have to generate the level, and then graph-based LSTM you have to apply. So whatever the levels you generate, graph-based LSTM, this LSTM will now take care of this thing, and finally you have to get a level. So how you are modeling, this is modeled as a regression problem. So for each node, based on the level and embedding value, finally you generate a continuous value, regressed value, and that will be the influence capability of that particular node. After that, you take the top k, whatever k is given, top k you choose. And what can be the levels? You can use the standard algorithm. So for example, for each node, generally you can take you just see this thing. Next. Okay. So one thing that we have taken is that the degree centrality, then H index, and the K cell of a node. So the three component is now next. So if you divide by maximum value of this thing, it will become 0 to 1. This is some kind of normalization. And then normalized value of this centralities of all nodes form a future matrix. So this is n cross 3 matrix. So one can take a more futures also. So this PU, QU, and RU. So these are the future for each node you compute. Next, the embedding. Embedding is equal to the one column, one row of this particular matrix is equal to embedding. Next. Okay, level generation. For any regression-based methodology, you require a well-defined continuous level to which the futures value can be regressed. To calculate this level along the lines of transfer learning, we use there is something called a concept called transfer learning. So you learn from one network, and then when a new network is there, same knowledge you transfer to other thing. And this network on which you do, this should be also a complex network should have these two properties, scale-free property and then power law property. If you can generate that thing, from that you learn it, and whatever you have learned, that you transfer to new network, and then regress for each node. And then once you have the regression value of each node, from that now you choose the top k value. Next. So Barresi-Albert model is chosen for generating the training network, as it is among the most widely used synthetic network and has a significant resemblance to many real-life networks. So this is basically to get some kind of level generation. Of course, testing thing, you have so many data sets, real data sets are available. Then societable SIR model is used for level propagation. Next. So the generated embedding and the levels for suitable data set conforming to the needs of classical regression problem. One of the best performance with embedding is LSTM. And another purpose of choosing LSTM is that LSTM tackles the problem of vanishing gradient fairly well. And yeah, maybe 1 minute. I'll take. Okay, please go ahead. Move the slides. Okay. Just go. I'll send. Okay. Okay. The graph-based LSTM is this thing, embedding layer. After that, LSTM layer 120 units have been taken. Then dense layer 32 neurons, one network comes, and regress layer, and then this is a graph neural network. So what will happen? One graph will be transformed to another graph. Only levels and embedding will now change, keep on changing. At the end, and how do you do? There are some rules using which from the neighbors, because it is a global property, from neighbors you extract and then you aggregate it. So over the steps, information will come from every node to this particular node, and finally regress value you will get. So finally you predict the influence. You just quickly show the result once. Okay. Next. Transfer learning is basically this is where you learn it, and then target network you apply, and finally evaluate the various performance metrics. So whatever the data set we have seen, we have applied to those. Next. Just move it further. Okay, so these are the data sets which have been used, and they have been used in other papers. The 2 papers I showed. Next. Okay. Next, you just next. Okay, so these are infector scale. So you can see that, okay, something like this. This is what is happening. So this is the thing. Most of the cases, it is outperforming the current best neural network based method, graph neural network based method. Please keep going. I don't have time now much. Okay. So for example, here you can see, so the graph LSTM now it is giving better result than these are the two, this is RCN, this is the neural network based this thing, graph neural network. We have improved to quite high margin to all these things. Next, you just go. Next. Okay, so this talk was based on, though there is no time because I require a lot of time to explain, but at least 2 things you see. What is the influence maximization problem? How to design an algorithm. Today or tomorrow also you can design your own algorithm. Who can be the spreader? Basically you have to choose. But now if you want to use machine learning, then you have to do little bit this thing. So this is the paper that I was talking about, where this LSTM technique, now it came in expert system with applications. Another work that I have not discussed is also accepted, it published in Information Sciences. This is maximization in social network using graph embedding and graph neural network. This also gives some better results. So these are some very current one, 2023-24. This is how I'm just learning. These are big people who have working in the area for several years. But I am interested in doing something. Graph neural network is a very recent concept, and I'm sure it will be there for at least 10 more years. Because if you see, at least 40% of data sets that you see are graph-based data sets. Some of them I have shown it. And because of this thing, this is one important area to work with. And if you work in other areas, then it will be very good. Then you can know or do much better. But others also who are working in graph theory, graph algorithm, basically, they can also do, saying that, okay, they can also do a little bit of machine learning. That's the objective. Okay, thank you.
Thank you, sir, for this elaborative technical talk. Is there any questions? I hope no. Offline we can discuss.
In the first level, if you don't use machine learning, you can publish a paper in 1 month. Because if you see, thousands of papers have been there, lot of review papers are there. ACM review, ACM computing survey, papers have come up. So this is very active area of research.
So we'll have the memento ceremony now. May I request our convener, sir, to present love from the organizing committee to our speaker. Audience, please give him some applause. So we'll have a 5 minutes break for tea, but the session will continue. Morning, I took you all to Mexico. Then we'll ended back to Temple City. Now we'll go to USA. For the technical session, keynote address 8, we have with us our speaker, a distinguished speaker, Engineer Uma Maheshwar A. Kakinada, Principal Engineer 2, Emerging Technologies, Research and Development, Chatter Communications, Colorado, USA. The title of his talk is Emerging Topics in Wireless and Network Communications, a Standards Perspective. To give a brief about the speaker, sir is currently at Chatter Communications as Principal Engineer. Director in Wireless R&D. His primary responsibilities in this position are research and development of next generation wireless technologies, assimilation of these technologies into products and solutions, and participating and developing networking standards in various standard bodies such as 3GPP, LoRa, CBRS, ONGO, One Forum, etc. He is an inventor with 24 US and international granted patents, with some more in the process. He has a master's in engineering management from Northwestern University, another in computer science from Illinois Institute of Technology, and about 30 years of industry experience in R&D organizations of leading vendors and operators in wired and wireless networks. So we are happy to have you, sir, with us
Thank you.
as our technical speaker. Over to you, sir, please.
Thank you. Thank you for the kind and generous introduction, madam. How do I share the slides?
Sir, you are not audible.
Can you hear me?
Sir, please make your video on.
Yes, I've turned the video on, and can you hear me now, please?
Sir,
Are
please
you able to
unmute.
hear me now? I have unmuted myself as well, but can you hear me? Okay. Sorry about that. Are you able to hear me?
Yes, I can hear you.
Okay, thank you. And how do I share the slides? Is there a link for me to share? Or I have sent the slides to
In the bottom, I think you can click on present now. You can select the icons, and there's a option called present now.
Yes. Yeah, okay, got it. Are you able to see on my screen? Can someone confirm, please, if you are able to see my screen?
Yes.
Okay, thank you. I understand I'm between the lunch and current time and presentation, so I will try to be as concise as possible. So my topic is on the emerging topics in the, like, I will just try to describe how the evolution and progression happening from the 3G to 4G networks, then to 5G, which is currently being deployed in many parts of the world, and then how the evolution is going to what's the 6G networks, the what is being referred to as next G networks, and then also current hot topic, which is kind of probably going to transform many things, as we know, that is like the metaverse. We will briefly look at it. Given the time constraint, each of these things can have its own session perhaps, but given the time constraint, we will try to be as concise as possible, and we'll go from there. So basically, typically in wireless networks, we have a bunch of devices catering to different needs, and we have a heterogeneous access networks catering to these devices based on their data throughput needs and basically connectivity needs, latency needs, how much data they need to send, how quickly they need to send, and this. And then the core networks to cater to multiple devices and convergence of multiple access into this one. And then the applications, actually the purpose-built applications, many of the apps, these have become very common. And since the advent of iPhone, the application space has
evolved very, very rapidly. We have seen many of us what are the era before iPhone and how much constrained we were in developing the apps on the mobile devices and how much it has changed since then. And we will look at different aspects of it and also the transformative changes that bring to the society in terms of, like we have seen, like currently, whatever the different apps like the Uber, Ola, and the different door delivery applications, everything, and effect of the economy and way of life is very, very significant. So the next evolution, what it is bringing to us, at this point, we probably cannot predict, but we can make some educated guesses about that. So we will take a look at some of the use cases on what is the current evolution has brought to us and how the next evolution likely to bring to us. And so for the why standards are needed and what does it provide. So basically, see, we have diverse and we are able to communicate across continents, across oceans. It is possible just because we have a common understanding of expectations and interfaces are standardized. So the standards play a significant role in seamless integration of technologies and interoperability of different devices, networks, infrastructure, and everything else which is coming in between, right? The reduction of complexity, reduction of cost, interoperability enhancement, and leveraging different things which are developed across different things. So, for example, the IP world and the wireless world, the connected world and the wireless world was fairly distinct for a long duration of time. But all that has changed.
Excuse me.
Yeah, hi.
Umagaru, can you hear me?
Yeah, I can hear you, sir.
Yeah, but we are not able to sync your talk with your slides. So if you give instruction for changing the slide, then students will accordingly change the slides.
Oh, okay.
We are still in the first slide.
Okay, I actually am in the third slide.
Okay. Can you see the slides on the screen?
Let me. Okay.
Slide number
okay.
3.
Okay. Okay. If you can change the slides, I can talk through that. That's if that works better. We can do that.
No, but you have to tell that to change the slide.
Okay, sure. Okay. I will do that. So, I mean, this is the slide we are in. So that's good. We can talk about this one. So here, as I was saying, that is there echo? Okay. The need for standards in communication networks, why it is there, and what happens. And here I have tried to list some of the leading standardization organizations. 3GPP, which deals with our 4G, 5G networks, and the next G also, whatever comes. You can see the logos for LTE, the 4G network, and 5G network. And ETSI is a European standards organization which works in close collaboration with this one. And GSMA is basically the mobile network operators. Even though standardization happens, the telephone networks across the continents internationally, they have to interact. Then there are some profiles and common values need to be used, which is kind of facilitated by the standards, but common values are agreed by GSMA. And then we have IETF, the IP networks, all of are familiar with, and IEEE, the Wi-Fi access we use, and other things which come from the IEEE organization. And this is a university setting, and many of the speakers and students are probably members and senior members of this organization. So I don't need to say more about that. So next slide, please. And here LTE architecture, it is considered it started around 2006-7, the standardization, but the deployments happened around 2012 or so. So here it was considered to be relatively flat architecture. Many of the previous network elements hierarchies were taken away, and mostly the control plane, user plane separation was to large extent was achieved. So only things which were kind of combined in the control and user plane were the boxes I'm showing here, serving gateway and PDN gateway, S gateway and P gateway. These are, if you notice, maybe it is not very clear. So, but it's green and blue. That means it has both control and user plane, and functionalities embedded in this. So all these other things which are blue, solid blue, those are kind of user control plane functionality only, basically. And this red, orange nodes, basically the radio access network interface with the wireless spectrum and provide the connectivity to the device. So besides this interface, the UU interface, everything else is a IP communication. But these are the point-to-point interfaces, and I will would like to draw your attention to that, and I would like to bring up when we look at the 5G architecture. So these are the point-to-point interfaces. There are connectivity to this, and then there is the application function, which is basically another user plane function. So from the device, it goes to the radio nodes, then does various control functions to get authenticated, authorized, and access to the services, and then go from there to avail the services from the applications. So next slide, please. And here, what we have seen, one of the things I would like to mention here is basically the control plane functions. Basically, if you have, say, so many devices, like, say, millions of devices, hundreds of millions of devices, and all those need connectivity, and once get connected, they have varying needs of data. So in some rural area, maybe the data growth or data needs are probably not as much. That may not be true, but let's make that assumption. So basically, in various places, the need for data and connectivity differs. So basically, these functions, what I'm trying to say is, they need differs, and the functionality we saw in the previous slide, it was combined into a single function. So the scalability of the from the operator's perspective, it was kind of was difficult. Even if they needed only more connectivity but less data, they had to scale it simultaneously. So the separation of control and user plane, which is usually referred to as CUPS, control plane user plane separation, that was one of the motivating factors, and it was actually a real need, because large population got connected. They need a lot of control plane connectivity, but the user plane also was growing simultaneously, but there may be a disparity between the growth of control and user plane, which needed to be addressed. This one here shows how these two things are kind of independently can be scaled up and done. So we can go to the next slide, please. And now coming back to 5G network. So to draw the contrast between whatever we saw in the 4G network, and this is the architecture of the 5G network, we have a lot more network functions here. And if we see this, this is a bus architecture. Basically, that means any network function can talk to anyone. So it is kind of a, I would say, significant departure from the previous 4G architecture we saw, where there is a, even though it is an IP connectivity, like MME was talking to serving gateway was talking to PDN gateway, and the policy function was talking between PDN gateway and application function. But here, that means each of the function has to talk. If you were to add a new function, there was a lot of resistance because it meant like adding a new interface and a new connectivity, defining a new. So when the bus architecture came in 5G, so basically any function within the network, it is a kind of a subscriber and consumer model in that. So the subscriber says, what is that I am subscribing to, and the provider will provide according to his needs. So if they both of them agree on what is being subscribed and what is being provided, they don't need to have a predefined interface because it's a common bus architecture. Any function here, but it is not there is some need for discipline and what is being published and how the sequence of messages will happen. But still, any addition of new functionality, incorporation of new functionality, and addition of a new network function, it's not as restrictive as it was before. Also, the control and user plane separation. So we saw so many of these blue boxes, and we have few radio boxes which you cannot wish away. And we have one control for user plane function, the green one, UPF. So you can have multiple UPFs depending on the type of connections with edge computing and other things happening. So it's kind of a so whatever we achieved in 4G, kind of a relatively flat architecture, then in the kind of next generation, next advanced 4G, somewhat separation of control and user plane functions and ability to independent scaling. Those considerations came into 5G network architecture and also further enhanced to large extent. So let's go to the next slide, please. And here, these are the current activities. We will see the release roadmap. Currently, the 3GPP, which is the organization responsible for the wireless standards, these are the activities which are being taken in 3GPP. So the yellow ones I highlighted are some of the things which are kind of my personal areas of interest, and also I follow through them pretty closely. It's AI/ML operations, and then the edge computing and network automation. So these are some of the areas I thought would be of interest for the audience here also. So these are the topics which are being discussed. So currently inactive, and there are the 3GPP meets almost. These are the activities I'm talking in the system architecture group. And once the requirements are defined, the system architecture group works, and subsequently the actual protocol details are worked in within different groups in this. And finally, this whole process of standardization for a given release happens over a period of 2.5 years. It's a pretty long time, lot of nitty-gritty details, all the way from requirements to the architecture to protocol details of exchanges of messages and incorporation of functionality is looked in very finer detail, because without that, the interoperability would not happen. So let's go to the next slide, please. Okay, so this is the release timeline. Just for your reference, I try to incorporate. As you can see, that entire release would be happening end of next year. So, but this is likely to get delayed a little bit, and COVID was not kind to all these activities, large gatherings of meetings. And these meetings happen in a global setting across representatives from different governments and operators, equipment manufacturers, device manufacturers, network function vendors. everybody joins. And so it's a large gathering. Last one was in Toulouse in France last month. So this was the first meeting, which was a face-to-face meeting after 2.5 years. Nothing happened in, obviously, in 2020 later part as well as 21. So this was a kind of refreshing from that point of view. So let's go to the next one, please. Okay, this is the Next G Alliance, which is the, I would call the 6G. So if you follow through from 4G to 5G, and Next G is basically, it is, you can kind of notice a trend of paradigm shift across these different generations of networks. One of the things is, so 3G was there, then 4G was kind of a flat architecture, then the control user plane separation, and then 5G is kind of a interconnectivity across and lot of data throughput. And so the economic and social impacts of these changes are very transformative. Before the advent of like iPhone came in 2007, and this was, there were previous smartphones were available starting in 2004 and 2005, but they didn't make as much impact. But once the network transformation happened from 3G to 4G, and migration operators migrated towards the 4G network, the data ubiquitous connectivity and availability, all these significantly changed the society at large. We have all kind of services, connectivity, and also the regulatory bodies, governments, they stepped up and made it more accessible, both in terms of the connectivity and changing the tariffs for the bandwidth. I mean, early on in late 90s, it used to cost 50 cents per minute to make a cellular call. Now it is unlimited minutes as much, and unlimited data as well. So all that has a significant. I was actually thinking about gathering some statistics on the things, but I would encourage probably the students here to look at societal impact of this. So from 6G, it can be another huge transformative change given these goals here. So these are indeed very audacious goals. One is the social aspects of it, and the energy, the digital connectivity, and sustainability of different things. All these are major goals, and this will not happen in all in one release, or maybe the first glimpses of 6G, as we call, we'll see in like 2030s and early 2030s, but there will be a progression from there. But the reason I'm trying to say, like, this will be transformative. Many of the things which are kind of already people are talking about it, and there are no enablers for it. For example, metaverse, we will look at it quickly. But the enablers, the idea is networking is only part of it, but it is a significant enabler, and it would need to come in place to bring those transformative changes, in my opinion. Can you please go to the next slide? And these are some of the study areas. We can see digital twins, mobile robots, and other tactile internet, 5G, and beyond 5G, and basically intelligent resource management. This can be construed across multiple domains, basically human-computer interactions. Whatever we started with, many of us with the gray hairs, the human-computer interaction means like CRT monitors with 80 by 40, 80 by 25 actually. characters on the screen, and everything is character display, not even graphics. Probably current day generation who have come across computers in the after the year 2000, they wouldn't even cannot relate to it. So this human-computer interaction would be significant change. What would be happening? And edge computing and cloud computing, all of us are familiar with it at this time to some extent, and are also using it probably largely consciously, unconsciously. But there are a lot of regulatory aspects and compliance aspects, privacy aspects, what data can be disclosed, in what form it can be disclosed. That plays a significant role across the geographic boundaries, regulatory boundaries. Sorry, how am I doing in the time, in terms of time? How much time do we have?
10 minutes.
10 minutes, okay, sure. Thank you. So let's go to the next slide, please. This is the release timeline. As I was alluding to, it was projected to be in 2028 something, but it may go further down. So first standards realization may happen for 6G in our next G, what is being called in 2030, and the deployment will be further out. So the technology cycles from 3G to 4G has reduced significantly. 3G was there for 20 years, 4G maybe about 10 years, and now 5G is already in place in many places, and 6G is coming probably within 10 years after 5G. So technology cycle has shortened as expected, but that is probably a good thing. So let's go to the next one, please. And here I would like to draw your attention, like the human interactions part, whatever we're talking about. So I have a couple of illustrative examples coming up, but what is the tactile and multimodal communications? Basically, when the communication was happening, it was audio, video, but there was no other factors that were taken into consideration, right? So like, what is the feeling of that emotional expressions of the person, and the gathering of data. And if you would have probably noticed, like one of the topics of the 5G currently in discussion, standards being developed, personal IoT networks and the different sensory devices. So it's not only communication. When it comes to the next level of things, realization of metaverse, if you will, basically it's not just the communication. Communication is just an enabler, but besides that, a lot of tactile, haptic aspects which need to be like the sensors need to gather this information, communicate in a fashion which can be realized at the other end, and there should be a kind of a receptors which can take this information and actually provide that feeling. So all this is kind of a it could have been a science fiction, but it's getting there. And if 20 years back it was a science fiction, and then now we are getting closer to reality. And some extent with the advent of different devices, we are seeing in the marketplace also from Facebook and other players in the domain. So it's getting there. So one is sensing of their devices from the person there, and then the rendering of the information sensed and transported to the network through these devices. That was it. So can we go to the next one, please? And that is the description of what we talked over there. We can just move on to the next one in the interest of time. Okay, so this is the various definitions of metaverse, if you see. And as I was saying, whatever is the science fiction, there was a book in 1992, I believe, 30 years ago, exactly. And that book, Snow Crash, was first like characterize this term metaverse, and now definitions from different things, as you can see here. So I will not go through in detail, but to summarize across all these definitions from Wall Street Journal, McKinsey, Accenture, and the pioneer of this, Mark Zuckerberg. So you can see that it's immersive, virtualized connectivity, immersive connectivity in a virtualized world. I mean, to me, if we were to really summarize in a brief thing, what this means is immersive connectivity in a virtualized world, and kind of a blending of virtual and real worlds. That is what it is, and it is called augmented reality, virtual reality, mixed reality. And 3GPP standards, if you look at the topics I had listed, one of the things there, it was listed as XR. So that's XR stands for all these kind of realities, extended reality. So which is a combination of all these different flavors of realities we have been talking about. So can we go to the next slide, please? And so these are the features, vision, the enablers. Basically, what is that communication network? As I said, the sensory devices play a significant role in the realization of metaverse, and the infrastructure, communication infrastructure, can provide a low latency, high throughput, ultra reliable connectivity. So that's all the communication network. And also some of the things like which probably were not significant before, but in video it was there. Like as in the beginning of the presentation, we were having this problem of the video and the audio were not synced up. But here we have other sensory devices, and there may be hundreds of aspects which need to be synchronized, and the challenges associated with, and how do we make constructs to the protocol data units or PDU sets, whatever we are being termed as, like from the sensory devices, they need to be delivered in time and delivered together and need to be rendered in a harmonized, synchronized manner. So if all those things are not accomplished, then that may be futile. Whenever you are just one single packet is dropped from a PDU set for a given kind of experience, that may ruin everything. So I hope I'm trying to depict the importance of the communication network in terms of how to make it real. But there are a lot of things that need to happen in the platform and devices and the infrastructure as well. So can we go to the next one, please? And this is the one of the depiction of this, the platform, infrastructure, and devices and connectivity needs. So we can move on to the next slide. Here you can see, like in the top left picture, we have 4 different segments. There is a snow, and there is a kind of a just before the sunset, a traffic flow method. So it's just not the communication, what aspects of it, how much of the, how do you maintain the kind of a parity between the real world and the virtual world. I mean, our senses are very, very sensitive, and they are super smart. When those need to be replicated across domains, across geographies, and over long distances through a communication network, it is a significant challenge. And digital twins, whatever is being referred to, it's like an aircraft takes off, lands, it happens in different weather conditions, different parts have different wear and tear, and predicting what would happen with the different components. So those are very fine electrical, mechanical aspects and engineering aspects. So, but that itself has been challenging. But when we bring it to the very other, not very deeply understood as much as the technical complexities of this machinery, but those need to be replicated, and that the senses need to appreciate it. The challenges of digital twin in kind of a metaverse world is significantly more than whatever you would happen, for example, for a aircraft thing. So let's go to the next slide, please. And here we can see there are participants who are physically in the room, and there are participants with that telepresence, and maybe somebody joining through the video, and all of them sharing and collaborating on a project where they are trying to accomplish a task and collaborating on this and sharing information and feeling the same perception of the project and environment they are working in. And if it is very domain specific intricacies and constraints will come into picture, and all that the sensory and a rendering of that information gathered through the variety of sensors is a significant challenge, and communication is an important part of it, but there are a lot of other aspects which need to be taken into consideration. I think that probably is my last slide. We can go to the next one. Yes, that was the last one. Thank you. Any questions, Sujan?
Thank you, Uma. Thank you for
Thank
the
you.
support. By the way, what is
Thank
your
you.
time now?
It's pretty close to midnight. That's
Midnight.
yeah, pretty close to 11:55.
Okay. Thank you for your support during the
Sure.
midnight itself.
Absolutely, and it is my pleasure, and I'm really grateful for this opportunity to share my thoughts.
Can I ask a question?
Any questions
please.
from the audience side?
Yeah, so I will ask the first question. Yeah, it was a great enlightening talk. Some basic question about digital twins. So, like, what is the difference between digital twin and a simulation? Like, what is enhanced in case of a digital twin, which is not possible through simulation?
Okay, so in simulations, I'm a communications guy, so this is probably a different field in itself, but I will try to make an attempt. So digital twin is basically exact replica of whatever is happening. Because let's take an example of a simulation of a network, right? So we say, let us say there are 100 base stations, a core network, and there are so many devices. You simulate different scenarios. But say, as opposed to a digital twin, like I suppose aircraft is making a takeoff and landing, and it is doing in different environments, different conditions. So simulation is kind of tries to close, approximate whatever is happening in a real world. In digital twin is exact replica of whatever is actually happening for a given domain or given thing. So in case of aircraft example, so if you have a digital twin, you know that this is the weather condition and which it landed, and these are the gears which have a different stress or strain. So all those things, like all those conditions which the equipment or different factors are subjected to, are exactly tried to replicate it. In case of simulation, all those scenarios, it's like a close approximation. So, I mean, roughly speaking, from my understanding, digital twin is like a lot closer to the reality and more like accurate predictor of the situations that may come, as opposed to a simulation environment. Like you have an elevator, so IBM Watson ad was there, right? So it says that Watson told me that this elevator belt is going to fail next month, so replace it now. So simulation can do it, but it will be more coarse-grained, and digital twin will be more fine-grained, in my opinion.
Yeah, thank you. I have another question regarding metaverse. So, like, there was a lot of hype about metaverse, but it seemed to not have realized its full potential. Like, there was a lot of noise about metaverse and that it will revolutionize how people interact with each other or maybe interact in the digital world, but it hasn't come to reality.
Yes,
So,
I agree with you 100%. And also, to be fair, I mean, it's a grandiose vision at this time, and things have start that way. And I hope it materializes. And the proponents of this are like from Zuckerberg. He probably is in younger and also have a lot of resources at his disposal, and those are the factors. And other thing is the enablers of the technology. Say, for example, we had 3G, which is kind of giving us like 1 meg speed. In 4G, we were getting about maybe tens of megs of speed. With 5G, we are getting gigabits of speed, and latency has reduced significantly. So the 6G next generation network, whatever we are thinking about, so URLLC, like ultra reliable low latency networks are coming. And also there are things which are like I listed in the 5G. So there is a convergence of bandwidth across wired, wireless networks and everything. So there is a humongous amount of bandwidth is generated. So the enablers needed from connectivity perspective are being realized. So, I mean, any technology, anything to come. So the enablers and the business needs and viability. If you look at the whatever we are calling 6G, next G, audacious goals, if those materialize, they would enable. And also the sensory networks and the rendering this. And after all, it has to also make a business sense. Like, I understand at this point, there are many operators in South Korea, like SK Telecom, and in Japan, there are some operators have started AR-based advertising. So it is getting there. It's not, I mean, I am not a big proponent of metaverse, but it may transform things. We don't know what is the killer app for that one. So, but once the enablers come into place and the needs evolve for that, and that will make some transformative changes. I am hopeful, but yeah, I mean, many things fizzled out, right? IoT, smart cities. I was working on that, so it hasn't stepped up to its potential.
Thank you very much. I have another last question. So this question is related to 5G versus low Earth orbit satellite networks. So one issue with 5G is that it requires dense deployment because the signal strength drops significantly with distance compared to 4G, and like you need to deploy more antennas. People are saying that this low Earth orbit satellite networks like Starlink are a better solution for connectivity compared to, say, 5G. And another thing was that people were talking about 5G and they were relating it to smart city and vehicular networks and how it will transform modern life. But at least for now, it doesn't seem to have been realized.
Okay, so I mean, there are quite a few things you mentioned. So let's maybe take step by step, like looking at the low Earth orbits and of the. So one of the things is 5G network and low Earth orbit network. So for larger throughputs, huge amount of data, you need spectrum, right? When you have so spectrum, when you use it at 5G networks, as you rightly pointed out, you need dense networks. Why that the dense network is needed? The spectrum at higher the FR2 bands, like say 28 or 40, 50 gigahertz, their reachability is very less. That's why you need a dense network. And also they need to cater to the larger throughput. So if you take that throughput thing into the low Earth orbits, it's low Earth orbit satellites, it's difficult to realize that. And also the density of the device that it needs to cater to, how much spectrum the satellites, and also the satellites are super expensive compared to terrestrial, whatever the 5G networks you can deploy in this. So it's one is the expensive, like Motorola. I worked for Motorola for a while, so had the Iridium project in only when there are disasters like 1999, the cyclone we had in Odisha. That's only phones that were available were satellite phones, and those are good for that. But for normal usage and for a significant bandwidth, which we have come to become used to, it's difficult. I mean, but those were earlier ones were like really geostatic satellites, and these are low Earth orbit satellites, and the financial distress, which of the, I mean, OneWeb was the one company which comes to mind, and then we have SpaceX, we have Amazon trying to do these things. It remains to be seen if it is a business case wise, it's a viable, because the all previous iterations, even OneWeb with the deep pockets of a Japanese consortium, they had to go through bankruptcy last year. So I'm not very hopeful about OLE, like low Earth orbits kind of solutions because of the throughput needs, but only time will tell.
Okay. Yeah. Thank you very much, sir.
Okay. Thank you. Really enjoyed this discussion.
Thank you, sir.
Thank
Sir,
you.
This is Mrutyunjay Panda, sir,
Yeah,
convener of this
thank you,
conference.
sir. Nice interacting with you.
Sir, on behalf of Utkal University fraternity and from the Department of Computer Science and Application family, we extend heartfelt thanks to you, sir, for accepting our invitation and giving such a beautiful talk today. So
Thank
we
you.
are
It's my
grateful
pleasure.
to you for kind acceptance and make us proud for this talk, sir. Thank you very much.
Thank you. My pleasure. Thank you.
Sir, sometime
Really
we
enjoyed
will,
it.
sir, we will call you to come here physically so that we
Yeah,
can have a research
whenever I'm
collaboration,
visiting,
etc.
I'll definitely stop
Thank you,
by.
sir. Thank you so
Thank you.
much. Have a good day, sir.
You too. Bye-bye.
Now, welcome back to the keynote address 9. For this ninth keynote address, we have a very youngest speaker, Dr. Aniket Mohanty from New Zealand. After today morning, we went to Mexico, then Temple City, then USA, and now we are on our way to New Zealand. Dr. Aniket Mohanty is a researcher, educator, award-winning author, and a very brilliant student. He brings over 15 years of experience in designing, measuring, analyzing, and modeling complex distributed systems. Currently, he is a senior lecturer, just like our associate professor of computer science at the University of Auckland. He has received his doctorate in computer science from the University of Calgary, Canada in 2012. Between 2006 and 2008, he has worked as a research associate with the Computer Networks Group at the University of Calgary. His expertise spans multiple domains such as computer science, social sciences, and business. His post-secondary education was fully funded by prestigious scholarships like the National Natural Sciences and Engineering Research Council of Canada, Canada Graduate Scholarship, and the Provincial Alberta Innovates Technology Features Graduate Student Scholarship. He has received Best Paper Awards at international conferences on smart and sustainable agriculture in 2021. During today's discourse, he will talk about designing a software framework based on an object detection model and a fuzzy logic system for weed detection and pasture assessment. So we are happy to have you here, and you started with a very nice discussion. Now welcome to ICIICC 2022. Over to you, sir.
Thank you very much for the introduction. Let me share my slides. Yeah, just 1 second. So are you able to see my slide?
We could able to see it.
Yes, I will just do present view. So now you can still see the slides?
Yes.
Just the slides, right? So not my notes.
Thank you.
Okay. So thank you very much for allowing me to give this talk. So the topic of my talk is what was mentioned in the introduction, but here is a more precise title: a digital agri-precision application for pasture cleanup. So this work was primarily done by my PhD student who was working on this problem for some time, and he was a business and information system student. So he was looking for a business problem that he can solve, and in New Zealand, agriculture is a major source of revenue, so he focused on this topic. So let's start with some background. So the talk is about precision agriculture. So let's understand what is precision agriculture or agri-precision. So agri-precision is basically a combination of agriculture data plus smart applications for processing information from the farms. So the agriculture data comes from farms through sensors. So it could be different types of sensors, like sensors that tell us the rainfall, sensors that tell us the moisture in the soil, or if you're talking about animal husbandry, which is the case in New Zealand, then it could be talking about the temperature of the animal and other things. So the data can come in different forms. It could be in text form, or it could be in images. And this data can be utilized for several purposes. So we can, for example, use image processing models to understand the data that is being sent by the sensors for making decisions. So we have to build some models and applications to serve our purpose. And the main goal behind precision agriculture is to increase automation, so removal of manual tasks and doing a lot of the things automatically or through machines. So this is what I already mentioned is what is agri-precision. It's basically a combination of agriculture and technology. And in case of technology, we are focusing on three different topics. One is artificial intelligence, the other one is machine learning, and the data that is coming from IoT or Internet of Things. So we gather data from these sensors, which are connected to the internet, and then they feed data to these machine learning models who can be trained to do many interesting things and then do prediction or, say, clustering of information. So IoT will provide the sensing data, and AI and machine learning will help process the data and allow us to make decisions. So there are several examples of precision agriculture. So basically, this is the combination of new data and new data processing models to define a new application. So I have listed several examples, and these examples are quite prominent. So the one which is about animals, and that is more relevant in countries like New Zealand, Australia, or other Western countries, where animals roam in farms, and they provide meat and dairy. So in case of animal monitoring, you have these sensors which are attached to the animals, so that they can be used for measuring the temperature. And that temperature information is important for understanding the health of the animal, and as well as whether what is the time for the calving, which is the birth of a calf. And then these models, AI models, can be used for predicting the calving time. So when will the calf be born? Another example of animal monitoring is geosensing of animals for controlling them inside a field. So for that, we can use image processing and geolocation models. If we are just talking about crops, then it can be used for monitoring the soil to detect the best time for planting of the crop. And then once the crop is growing, then we can use crop monitoring. So again, that will utilize image processing for forecasting the cultivation time. So when we will harvest the crop. If we are talking about like trees or forests, so then the health of the forest can be understood using images of the tree cover. We can look at the level of water in the river to understand the water needs of crops or how much moisture is in the ground. So for this particular talk, we will focus on pasture. Okay. So what is a pasture? Pasture is basically a field where animals can graze. So in the case of New Zealand, most of the milk and meat comes from grass-fed animals. So you have large lands which have just grass growing. So they have been cleared. They have no trees, just grass, and animals like cows and sheep graze on that grass for producing milk or other products. So it's different from where animals are fed grain and they don't have the space to roam around. So that's why our focus was on pasture management. And we wanted to understand what was the problem that farmers who herd these cows specifically. So in this case, we are focusing mostly on cows and pastures. So what are the problems they are facing? So we initially started with a survey, and we sent 30 questions to different farmers across different parts of New Zealand. So if you don't know about New Zealand is a small island which is located in the southern hemisphere next to Australia, and it is having two major islands, North Island and South Island. And it's a small country, so 5 million people. So there's a lot of free land for animals to graze, and that's why people say that there are more sheep than people in New Zealand. So the survey covered the current methods for pasture management by dairy farmers. So again, our focus is on dairy farmers, so cows grazing in grass. And the survey asked for two current tools that are used for managing the pasture. So what kind of pasture, and we wanted some pastoral data. So we did some simple processing of the data that we got from the survey. We use natural language processing and simple tools like Excel to understand what were the needs of these farmers. So I don't go through the entire survey, but what we realized was like what were the keywords that we found in the survey. So the keywords that we saw in the survey was weed, control, spray. So these were some of the most important words that came quite frequently in this survey, and that led us to the topic of weed management. And the second topic was words such as weed, no, method. So these are the ones that lead us to the topic of weed knowledge. So what information do we have about the different weeds that are growing in these pastures? Okay. So when we talk about agri-precision, then we focus on farm monitoring, so pasture monitoring. Now, when we have a farm, it can be of two different types. One is a pasture, as I told you, which is a grass growing on a field. So you can see the image here on the right-hand side. So you have just grass. That is a pasture. And you can have crops growing in your field, so which is on the left-hand side. So you will have certain crops. Maybe it could be a vegetable, it could be a fruit, but they are quite distinct. The main thing to know here is that crop monitoring is much easier than pasture monitoring. Why is that? Because in case of pasture monitoring, the pasture environment is fuzzy. The pastures are mixed with complicated patterns, shapes, colors, making it hard for detecting any image or object detection model. So for example, here in the image on the right hand side, you have a pasture. You have the background as green and you also have the foreground as green. So how do you identify a weed, which is an unwanted plant in a pasture, right? So but in case of crop farm, which is on the left hand side, you can see that it's mostly ground and then you have the crops growing. So the background and the foreground are distinct. So here you can use image detection, object detection to identify a weed rather easily. So weed is basically an unwanted plant. You don't want it to be growing in your farm. In case of pasture, if a weed is growing in the pasture, it will quickly take over the entire pasture, and the animals who are grazing there will not eat the weeds. So for example, a cow will not eat the weed, it will only eat the grass. So it's not productive for the farmers to have the weed. And for management of the weeds, you have different methods. So typically what the farmers will do is they will spray weed herbicide on the entire farm, entire pasture. So this is not really sustainable or environmentally friendly. So you want to do targeted weed removal. So manually removing weed is quite time consuming, and if we can automate that process, then that will be really nice. But weed detection in a pasture is problematic. So the environment is fuzzy. The pastures are mixed with complicated patterns. As I told you, there are different colors which are similar. And there could be empty spaces in case of a crop farm, which allows us for easier detection, which is not possible in case of pasture. So object detection in case of pasture is much harder. So we wanted to solve this problem. So we wanted to identify weeds in a pasture. We actually narrowed down on certain specific weeds which are most common. And we started to develop a weed detection model that can automatically identify the weed, and then it can be controlled in a more specific manner. So we haven't really deployed the entire system, but we envision that the weed detection model, which runs using machine learning, can be deployed on a robot, and then the robot can go through the entire farm and then identify where the weed is growing, and then it can kill the weed, maybe using precision amount of weed spray on just that weed, not the entire field. Or it can use other methods like hot water, which is more environmentally friendly, or maybe laser or something like that. So that is what we envision. So this is our system for weed detection. So there are different components. The first component shows the weed detection model, which is the machine learning model, which is typically an object detection model for processing the pasture data and detecting the weed. And then the second component is a fuzzy system defined for processing the converted images and assessing the pasture and understanding how much weed is there, how much empty space is there, empty ground, bare land. So no grass growing, no weeds growing, just empty patch. So for that, we need to put some grass seeds so that we can have grass growing there. And the last part is an evaluation system for understanding the accuracy of the model. So with machine learning model, you have to provide some input, and in this case, because this is object detection, so we have to provide images. Now with images, the more images you provide, the better your model becomes. Now in our case, we had a lot of problems. So one was COVID, so we were restricted to not going to the farm, and the farm was quite far from where my student was studying. So we could only go to the farm once, and we captured as many pictures as possible. So to grow our dataset, we focused on synthetic dataset. So in this case, we have created a synthetic dataset which can automate creating more photos. So we can take the weed as a foreground, and then we have different backgrounds, and we can combine them together to have more images for our data set. So for this, we have these two different sets, which is the weed, as you can see, like these green parts, like these, this one, and we can combine different weeds together, and we get this synthetic data set where we have the background, which is like fairly clean, or like nothing growing, and then you have these two weeds. So this is artificially generated. And then another one is like empty spaces. So these are bare pieces of land, nothing growing. So we can create more data sets from existing data sets for our model. So here we have a comparison between the real and synthetic data set, and what are the advantages and disadvantages. So the main takeaway or main point to learn is that there are more advantages of using synthetic data set. The first one is that we have short time for creating thousands of synthetic data sets, so they can be created much more quickly. And then we have the flexibility of adding noise or light and shading to the photo using code. And this is quite useful for experimentation. Among the advantages, there is no negative side which we see in our resulting photo. They look quite real. So the slide here shows a real photo of a pasture on the top, and then on the bottom we have two results of our model being trained by a synthetic data set. So this is our real picture. So here we have these weeds growing on the grass, and here we have two synthetic images where we have added more weed onto the background. So we have created more images. So what we see here is that the results are quite accurate with precise boundaries. So here we have our object detection model can identify the correct boundary of the weed. So it's not like a box. For most object detection models, it will create a bounding box. So here when you have like a star-shaped weed, this model that we used can actually find the real boundaries, not like a box. And it is also able to identify bare patches, which is like empty spots. So the slide here shows the original photo, which is here. And then the model that we use is Mask RCNN, which is a convolutional neural network model. And this is quite a good model for object detection. So it will receive the photos, and then it will show the weeds, and it will also show the bare pieces of land. So again, here you can see that it's showing the boundary of the weed that was identified here, and it can also identify some bare spaces of land. So here we are talking about the different components of the Mask RCNN model. That was our object detection model. It includes a head layer for processing the pure pixels of the photos. And then we have the blue bins, which show the filtering layers, which process the output of the head layer and apply segmentation and filter processing. These are the middle layers that prepare the foundation for detecting the boundaries of a weed. The yellow layer output shows the boundary of the detected object, whether it's the weed or it's the empty spot. Now, With mask RCNN, it is typically costly in training compared to other object detection models such as YOLO and SSD. So for a better accurate result, we can tune various parameters and hyperparameters such as learning rate, number of layers, and backbone. The quantification module connects two components of our application, the weed detection model and the fuzzy system. The quantification comes from receiving image pixels of detected weeds and empty spots and then converting them as the ratio of weed versus pasture. So how much of the land is covered by weed in the pasture and how much of the land is bare. So bareness divided by the pasture area. So we also created a fuzzy system for understanding the productivity of the field. So this fuzzy system contains three main parts, which are the fuzzy membership functions, the fuzzy engine, and the fuzzy fire. The fuzzy fire will convert the pixels into membership functions, which contain like linguistic parameters. The fuzzy engine is primarily for processing fuzzy membership functions. The main component of any fuzzy engine is the rules in the form of if-then conditions. And then the last part of the system is the defuzzifier for converting back the membership functions into crisp numbers. So something like this. Now here we are looking at the three components in a little bit more detail. The first part is showing the three conditions for both weed density and the bareness as represented by these triangular functions. The middle part shows the fuzzy rules, so if-then rules. And here we have 9 rules and you can create more rules. So for instance, the first rule indicates what should be said if both weed density and bareness are low. And then the third part is the assessment, which is represented by 5 membership functions like very poor, poor, average, good, and excellent. All the membership numbers can be changed to have better or less accuracy. So that is all adjustable. Now here we're looking at the network of our fuzzy system. We have 2 variables of weed density and bareness, which come into the system. And then
Excuse me, sir.
Yes.
Just can you go to the previous slide?
Yes.
This defuzzification, I would like to know a little bit more about it. Could you please throw some light, give some more details?
Yeah, so with basically we have the linguistic variables which are provided as input. So these are the triangular functions, and they have different linguistic parameters that are provided as variables, and then they are applied to rules. So you can create as many rules as possible. And then these rules will provide some crisp numbers. So for example, if the weed density is high and the bareness of the pasture is high, then the productivity is low. So that is what the defuzzification of the output will provide. So that is what is being shown here.
Thank you, sir.
Yeah. All right, so we look at this fuzzy MFE, which is our enhancement to the system. So we have 2 variables, which is the weed density and the bareness. So weed density and bareness, and we narrowed down on these 2 because they probably have the highest impact on the productivity. And then they are converted to different membership functions which are suitable for fuzzy system. And then we have fuzzy rules that are being applied to these variables. So all of these variables. And then based on certain criteria, a score can be calculated. So that we call this as a yield score, meaning how much productive that pasture is, how much productive that land is based on weed density and bareness. So that is what is being shown here. We have the vertical black line, which determines the situation of the field. So you can see it here, this black line. The first one is showing that it's pretty good. The second one is showing that it's similar to the first one, but a little bit far from being excellent. The filled area of the output membership function basically sums up to 1. So all of these shaded areas, they all add up to 1. And then we have a sliding bar. So based on all of that analysis, we get some scores. So to the previous image input, we have these yield scores. So how much is the density, how much is the bare patch, and how much is the yield score. So density would be a maximum of 1, bare patch will be a maximum of 1, and the yield score will be a maximum of 100. So in this case, so for example, this yield score for case 4 is quite high compared to the other cases. Now we wanted to create some artificial 2D maps of pasture. So this slide shows a virtual pasture made up of 10 by 10 tiles. So you have 10 image tiles and 10 image tiles here. So 100 tiles in together. And we use this for our research. And we wanted to get like a color to identify a color scheme to identify how much is the wheat density, the yield score, and the bareness. So the different colors represent the different properties. So we have the different colors. The shading of these colors will show how much is the bareness, how much is the wheat density, and based on these two values, you can get the productivity. So we can make some enhancement to the system, and that enhancement is the neuro fuzzy system. So for making our fuzzy system to be evaluated and trained, we added some weight parameters. And for the membership and the rules, the weights are obtained for their best values during the training process, leading to a better system accuracy. The rules are labeled from R1 to R9 here, as you can see here in the network. And then we have a weight which has been defined for each. And this is important to note that for each fuzzy parameter, whether it's a membership or a rule, we can define weight to enable them in the training process. And we can define the weight for all the parameters that we can get for the training process. And during the training, the weights find their best value and behave as a fraction to the fuzzy parameters, which is the best way of tuning them. And this process will lead to a much better accuracy in the assessment. So that is all about my work, which I did with my PhD student. My PhD student has a much better understanding, and he could probably give you a better explanation of the fuzzy system and the machine learning model. So I don't have that deep knowledge into how it was executed and what were the challenges and so on. So we have published this work in this conference called Smart and Sustainable Agriculture, and we got the best paper award for that paper. And we have another paper which was published in Transactions of Internet Technology, which covers the object detection model. So in this paper, which is mentioned on this slide, we are talking about the fuzzy logic based pasture assessment system, and the paper that appeared in Transactions of Internet Technology from ACM, and that discusses our object detection model, which utilized mask RCNN, and it looked at its performance and how accurate it was, or what was the F1 score and so on. So I would encourage you to look at those papers. So just to conclude, we discussed agri-precision application. We developed an object detection model that utilized mask RCNN, and then we developed a fuzzy inference system for assessing the productivity of a pasture. So yeah, that concludes my talk. So I think I finished my talk in 28 minutes. So thank you for joining me in this talk, and I will be very happy to answer.
Thank you very much, sir. Any questions, please?
Yeah.
Hello, Aniket. I'm Manas here. So it was a very interesting presentation. I can understand the need for this kind of research in New Zealand, which is basically an agriculture country. I think you have rightly chosen the topic. Okay, now the pasture management, I can understand the complexity that goes behind the pasture management. Now, I'm just curious to know whether it can be done on the fly when things are happening in real time, or you just capture the images and gather data from the pasture, do a bit of offline processing, and then you build a recommender system that can be passed on to, that can be used for the pasture management. So the question is whether it can be done real time, the real time pasture management.
It's a valid question, and it's a very important one. And we were discussing about that question when we were working on this problem. So currently, how it is designed, it works on static images. So static images can detect the weeds quite well. But of course, if you want to do automation, we would be dealing with moving objects. So object detection model needs to be capable to be able to handle different scenarios, different lighting conditions, and as well as movement. So currently, it is what you rightly mentioned. And of course, we would like to improve it. But we finished our project using just static images and offline processing and not on real time.
Yeah, thank you. The second part of the question is, you mentioned somewhere the use of NLP in the pasture management. Could you just elaborate where NLP comes into picture for pasture management?
So NLP is not used in the actual pasture management. So the NLP was used slightly in the analysis of the survey data from the farmers. So we just wanted to know what were the problems that the farmers were facing. So we sent a questionnaire to 100 farmers around the country, and we got responses from 70 people. And we wanted, and a lot of the responses were in free forms. It was not like not like check boxes. So we couldn't really like summarize the data. So a lot of free form information in comments. And for that, we used natural language processing and just wanted to identify some of the keywords which were appearing in the questionnaire response.
Okay, thank you.
Yeah, thank you very much for the questions.
Hello. Hello.
Yes,
AK Bisoi here. I have okay. I have two questions about the case when you have this weed and the grass both together. Both are green. So, what are the features or characteristics of images which distinguish these two between weed and grass? Both of them are green. This is question number one. The other question is, so after you detect the weeds, how accurate are the results? I mean, with what precision you can compare with the actual things? These are the two questions.
Yes. So they are again very valid questions, and these things we also were discussing when we were doing the project. So the identifying the features of the weed is important for the training of the object detection model. So in this case, we focused on one weed which is quite prominent. It's called California thistle. California thistle has a unique shape. In the presentation, you could see it's like more like star shaped, and it's broad leaf. So the difference between a weed and a grass is that weed is broad leaf, so its leaves is quite wide compared to grass. Grass has fine leaves, so that is one of the ways to distinguish weed from the grass. And of course, we have like different parameters which were used for building the model. And my student probably has the better answer as to what were the features and how it was fine-tuned. But I would encourage you to read our Transactions of Information Technology, Internet Technology paper, which has those details. The other one, which is the evaluation of the object detection model. Our object detection model did not do excellent. It was quite good. So in terms of performance, when you measure it using F1 score, our F1 score for certain cases was around 0.9 or 0.85. So we could have improved it, but again, due to the challenges of the circumstances, like the background and the foreground and the colors and the shapes, this is what we could do best. Another thing that we did was running our model on different platforms. So one was on powerful machine, and the other one was on resource constraints like Raspberry Pi. And in case of Raspberry Pi, the model worked quite well as well. So the response time was quite well. And if we were to deploy it on a robot, and if we were to do it on a real time, then we would need to deploy it on like a computer, like a Raspberry Pi resource constraint system with a cheap camera to detect the weeds. So it worked quite well, and there was some scope for improvement, but we found that it did quite well.
Thank you, Dr. Mathi. Thank you very much.
Yeah, thank you very much for these questions. Very enlightening.
Thank you, sir. Any more questions from the audience? It's okay, fine. Sir, thank you so much. This is Mrutyunjay Panda speaking. First of all, my sincere gratitude to you for accepting my invitation to give a keynote address for today's conference. Even though we have also started collaboration with Professor Aniket Mohanty, one of my PhD scholar is also associated with Professor Mohanty to see that some work we can do and we can have some collaborative publications.
Yes.
But we are yet to come into a good journal.
Yes.
Sir,
Yes.
yes.
But we will do that. Eventually, it will happen.
Yes, sir, definitely, sir. Thank you so much for inspiration and motivation to our students and also.
Yeah, and I really appreciate you inviting me to this conference. You have great list of speakers, so I was probably not a worthy keynote speaker because you have a lot more experience and well-known people giving talks in the conference. And the questions were really enlightening and helped me reflect on my work. So I really appreciate your time.
Thank you, sir. Thank you. Thank you, sir. And we also expect that sometime when you will visit India, we will invite you to our campus to have some physical interaction and to see that our students also get motivated by looking into your research areas and do some kind of research on precision agriculture and precision medicines using some AI and ML techniques and have some collaborative publications so that we can move ahead.
Definitely, yeah.
So thank you very much, sir, once again for from the Utkal University, from the Department of Computer Science and Application family, for accepting our invitation and giving such a beautiful and insightful talk. Thank you very much, sir.
Thank you. Thank you.
Thank you, sir.
technical session will start in the smart classroom. It is in participants are requested to move to that link and join. Four 4308 7647 list check करना ना डाटा कितना 8480 8480 8480 हाँ प्लीज कम हाँ हाँ सेम सेम मकान डाकिलोनी खिलर सांगू तेरे अच्छा
Very quickly. So we are getting started with the technical session number 5 that will happen in offline mode. All the papers are going to be presented offline. We have 4 papers and all the presenters are ready. We have all the 4 presenters here in this room. This session will be chaired by Dr. Pavitra Mohan Khilar from NIT Rourkela and Dr. Saurabh Kumar Bhoi from Parla Maharaja Engineering College, Berhampur, and co-chaired by Surajit Pradhan from GIIT. Go to session chair to conduct the presentations.
Okay, very good afternoon to everybody, and I welcome all of you to start presentation. So we'll go sequentially. Let us start from paper ID 8480 Akshay Kumar Mandal, and affiliation is Assam University, Silchar, India. Title is Machine Learning Approaches and Particle Swarm Optimization Based Clustering for the Human Monkey Virus Study. Okay, let us start. Please, Akshay Kumar Mandal.
Oh, sir. Yes, sir.
Thank you.
এটা কোন নিচে মধ্যে দেখে দিও এটা মুভ পাই ড্যাপ पे चले जाओ पॉइंट ऑफ हां ठीक Good afternoon, sir. I am Akshay Kumar Mandal. I am present my research work, our research work with from Pankaj Kumar Dev Sharma and Sachinanda Dev Sir, FM University, collaboration with the FM University. My work, our research work is machine learning approaches and particle swarm optimization based clustering for human monkeypox virus study. Actually, this paper is a advisory paper for monkeypox virus. This is my presentation outline. This is my, before writing paper, we fixed the objective. That are the objective of our research, to study the characteristics of monkeypox virus with literature on drug and vaccine design, diagnosis and prevention technique that help clinicians identify infection early and provide crucial data for the virus management. To study PSO-based clustering for monkeypox virus, analysis of monkeypox virus prediction and prevention techniques, exploring the application of possibility of PSO clustering in monkeypox virus detection and diagnosis. Not working. Introduction. The world is currently grappling with endemic fear because of the prevalence of monkeypox cases in various corners of the globe, even as threat of COVID-19 pandemic. The majority of the 2022 outbreak cases of monkeypox virus are found in Africa, now found in nations throughout the Europe and Western Hemisphere, with 10 instances of monkeypox virus recorded in August 2022 in India, along with the one death. The orthopix virus genus of Proxiviridae family contains a large number of genetic virus, including the monkeypox virus. The term monkeypox describes the disease because the first viral infection detected by this virus was in macaque monkeys in Democratic Republic of Congo. Then here, this picture represents the monkeypox classification. Then in this picture represents the different monkeypox cases in world, and also this graph represents the number of death cases. Then important definition. Machine learning is defined as a discipline of artificial intelligence that provides machine the ability to automatically learn from the data and past experience to identify patterns and make prediction with minimal human intervention. Today, with the rise of big data, IoT, and ubiquitous computing means real-time computing. Machine learning has become essential for disease diagnosis and prediction. That this picture represents the machine learning tools that are screening and treatment, contact tracing, prediction and forecasting, molecular study and drug design. Then monkeypox virus and its symptoms. The infectious virus that causes the illness in orthopox virus, which is responsible for causing monkeypox. It was named
monkeypox after being discovered in the monkey at Danish Research Center in 1959. As a young age of 9, was admitted into hospital with symptoms similar to smallpox in 1970 in the Republic of Congo, resulting the confirmation of the first human cases of this virus. A viral illness known as monkeypox can affect both human and other animals. The symptoms of monkeypox are fever, lymph nodes, and blistering, clustering rash are all the symptoms of monkeypox virus. Between 5 to 21 days passes explore and development of monkeypox virus. Symptom of monkeypox virus generally between 2 to 4 weeks. It can help without any symptom as well as with minor signs. There has not been any evidence that the distinct appearance of swelling of the gland and lesions because of fever and muscle aches are common throughout different outbreaks of monkeypox viruses. Then the machine learning for monkeypox viruses. Due to its data-driven nature, machine learning technique may be useful in determining the optimal method to treat individual infected with the monkeypox virus based on recent data or features of contagious viruses. It might also aid in the development of model of treatment of the disease and even the prediction treatment results. The medical staff may apply machine learning based model to anticipate the probability of infection, mortality rate with the effective private public sector cooperation using data for airlines, social media, traffic regions, and other monkeypox virus suspectable locations. There are different machine learning model available that are VGG16, RSNet 50, Inception V3. Because of its quicker processing speed, better effectiveness, and enhanced scale up, recent research has shown that mammal with bio-inspired methodology can modelize the health industry. There are numerous machine learning techniques for prediction of diagnosis of viruses that are help clinicians identify the infection early and provide the crucial data for virus management. Then POC clustering for human monkeypox virus. Clustering is a technique that combines similar data points from a given data set into the single groups. Few applications of clustering algorithm includes image comparison, pattern analysis, and picture segmentation. Data points are treated as the particle in particle swarm optimized approaches. The particle cluster is updated based on the cluster center velocity position using clustering method based on the particle swarm optimization. This is POC clustering for human monkeypox virus. We will also write a paper. This paper take the image of monkeypox and processing it and using POC optimizer that detect the monkeypox affected in persons that are published in press medical journals. That is PubMed. Then introduction to PSO. PSO is that is the basic of PSO. This basically the PSO algorithm, the behavior of birds, how the bird are collect food that are represented in this figure. The bird, we use the velocity to update the position of bird, and update the position we use this equation. Then image fitness test. The fitness test determines the primary accuracy of the segmented computed terminology scan image. The class of clusters that are evaluated by applying fitness metrics. The expression xn is equal to xn1 to XNK represent the each particle in cluster. Group of data clustering approaches are referring to swarm. The fitness function is used to rate the particle quality in image. The fitness matrix used in previously described enhanced particle swarm optimization clustering. Then stages of feature extraction. The lesions are extracted from the segmented images during feature extraction stage of the proposed system. We consider the area of affected regions or rashes, perimeter, circularity, and diameter are the parameters used to identify lesions. Therefore, to improve accuracy, the segmented image should be free from unnecessary irrelevant features. This provided an automatic disease identification of lesion in patient's photo, which is extremely desirable to assist doctor in diagnosis. Then skinning treatment. We all are familiar with skinning and treatment during the COVID-19 pandemic. During the COVID-19 pandemic, this is the most important thing. Like that, in monkeypox cases, first skinning the patient. Once the patient is skinning, then detected, we isolate the patient. If we isolated the patient, we minimize the infection of the monkeypox disease. Then some review of clinical research of human monkeypox virus. There are different symptoms of monkeypox. Then the initial research of monkeypox. Then secondary research of monkeypox. All the research we study and represent here. Then contact tracing. It is a vital part. We all are familiar during COVID-19. Once a person is tracing, then we isolate that person. Once we isolate that person, then the infection is minimized, and also the death issue is minimized, because we initially given the medical treatment of that patient. There are some review we present here using particle swarm optimization clustering. Then prediction and forecasting. Monkeypox virus detection parameter. There are different parameters. Then how the system evaluations. These are the paper according to these symptoms. Molecular research and drug development. Particle swarm optimization clustering can highly useful in getting ideas for drug discovery. According to this paper, few attempts have previously made in this sort of period to develop sustainable vaccine. For example, Brinkodivir and Tecovirimet. Hence, the development of drug and vaccination program against the monkeypox virus is essential for controlling the endemic. During reform, and drug reforming, also known as a drug response repositioning, is the process of discovering new pharmacological therapeutic uses for old and existing available drugs. The review of clinical research and drug design for human monkeypox virus depicts in table 3. That is. Molecular research of drug development, that are component of protection, then symptom sign and privilege treatment. Then existing challenges and vaccination. There are still problems which need to be overcome soon. Although ML and particle swarm optimization clustering have demonstrated enormous potential in fast fight against the endemic of monkeypox virus, the ML and PSO clustering techniques are applied for clinical data storage and processing as part of a semantic approach to enable simple and safe access. Smallpox vaccine may be immune to monkeypox virus. Younger are avoid to take smallpox vaccine because already in 1980 this smallpox is eliminated in world. People who have had smallpox immunized should continue to take precaution to protect themselves and also others. Summary and discussion. In the past, people believed that Africa was the primary source of uncommon genetic virus known as the monkeypox. Since May 2022, there have been several instances of monkeypox reported in the several countries that do not have often experienced the disease, including India, United States, United Kingdom, Spain, Portugal, and Canada. This article summarizes an automated estimate of monkeypox virus that was identified using machine learning and PSO clustering approach. It can challenge to distinguish monkeypox for other pox-like diseases because of the smallpox-like rash and typical prodromal symptoms. Then some recommendation testing at commercial and public health laboratory. Nucleic acid detection kit test for monkeypox virus, that is known as PCR. Also in case of, we all are familiar with PCR testing. And for the time of COVID-19 endemic, infection control guidelines and treatment of monkeypox medical wastage, because it is a contagious disease. So medical wastage, that is the most important things. Treatment of monkeypox with smallpox vaccines. Then conclusion. In this article, most of recent cutting-edge approaches of monkey machine learning and particle swarm antigen-based clustering technique are discussed to tackle challenges posed by monkeypox virus. In recent future, a single and reliable database of all the data related to monkeypox virus is necessary to design and implement efficient ML-based bio-inspired approaches for eliminating the occurrence of different endemics or monkeypox endemics. Then this is our reference. Thank you.
Presentation is over.
Thank you, sir.
If any questions from the audience side?
Please tell us your main results, what you have obtained.
Sir, before when start the monkeypox virus cases in India, my guide and Sachinanda Dev sir discuss each other how to write a paper so that people are awareness that monkeypox virus and doctor also awareness the monkeypox.
I'm just asking, you have done research. What is the result that you have obtained? What is your input? What is your output?
This is a study paper. We overall write down.
So this is not a research paper. This is a review paper.
Review paper, sir. Okay. We write also a paper. That paper is published in Press Medical Journal.
Okay, I can understand there's a review paper, but somewhere you mentioned machine learning techniques.
Sir.
At least by now you should have identified what are the machine learning techniques. Otherwise, you say machine learning is a vague term. No? It's a very generic term. Right? Sir. By now, in a review paper, if you would have included the specific machine learning techniques which people have been using for this kind of work, it would have been more interesting. That's all. Maybe we'll do that later. Thank you.
Thank you, sir.
Okay, next.
So, paper ID 2735, Suresh Devanapalli.
Yes. Large. Presentation mode. Presentation mode. Yes. 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 Back. Thank you, sir, for giving this opportunity. Respected session manager and chairpersons and all other delegates. Very good afternoon, everyone. I am Suresh Devanapalli, Research Scholar and Supervisor of Dr. K. Parindra sir. My paper title is Preparedness and an Improved RFID-based Authentication Protocol for Rail Transmit. This is the outline of my presentation. Is first one, introduction, mathematical preliminaries, review of JTAL protocol and weaknesses of JTAL protocol, discussions and conclusion reference. First one is introduction. RFID means radio frequency identification, and it becomes more popular due to the contactless automatic identification of objects, and it is low cost. This one is the basic structure of the RFID system. Here, RFID is reader connected to the antenna wirelessly and receive data from the RFID tag. And applications of RFID is the advantages of RFID system. It will simultaneously recognize massive amount of information. Therefore, the RFID-based solution widely applied to many applications. It includes healthcare to monitor the patient health and railway transportation. This one is some of the applications of RFID systems. RFID is widely used in railway transportation. For one thing, it plays more important role than train control system. So this one is the train control system. RFIDs can use to gather the train speed and location. However, the most important problem with the RFID system is that adversary can access the tag information, which gives rise to the privacy and forgery problems. Some mathematical preliminaries group, cyclic group. It is the, let assume the P is a prime number, let J is the generator of cyclic of order P. Discrete log problem. This problem is most useful in cryptography. So for finding the unique integer A is in between 0 to P minus 1 such that A is equal G power A mod P. In this one, capital A, small g, P are public keys, and small a is the secret key. So it is harder to calculate the for a large prime number. This one. So in this one, in the communication system, the key is the most important. For that, so the Diffie-Hellman key exchange algorithm is there. So based on this one, we can easily calculate the key, session key. In this one, sender and receiver have the small p and small g. And here, sender have the private key small a. He can compute capital A, G power M mod p, and forms a public key, capital A, GP, and send to the receiver. After getting the receiver, so receiver have the public private key B. He can calculate the capital B is equal G power M, and the public key of receiver is capital GP. Then sender and receiver have the public key and private keys. Then he can compute session key SK. So after he can communicate each other. Secure requirements in this protocol is untraceability and resistance of reply attack, forward secrecy, mutual authentication, and synchronization, scalability. Outline of the outline of the JTAL protocol is So this one is the outline of the Jodal protocol. In this one, so there is a weakness are there. The weakness of the Jodal protocol is so cryptanalysis Jodal protocol, it proves that it is not secure against the following attack. The first attack is the non-session specific temporary information attack. In this one, address enters the message to the reader and verifies the G power RT by using the RT. Adversary transfers the same message to the reader without any modifications. And from the message M, adversary can also decrypt the M by using the public key of the server. And also adversary knows the G power R, and he can calculate the easily session key by using the G power RT. And one more attack is there, tag impersonation and parallel session attack. So attacker knows the total details of the tag. So therefore he can forward the request message to the reader and impersonate the tag for the following reason. The privileged internal adversary of the server, also known this one, he can able to generate random variable RT star. He can calculate easily G power RT and N1 star. And also adversary sends the correct message to the reader and server. So thus the adversary can impersonate the tag. One more attack is there in this one. Internal privileged adversary can have the compute MS that means message. So he can interrupt N3 and N4. So server can send the same message to reader and tag. Here A knows RT star and RR star can calculate the session key. Session key is SK is equal G power RT star and RR star. Thus the A can independently calculate the session key. It making this scheme is vulnerable to the parallel session attack. So the next one is the lack of scalability. So in this one is step number 7. So server investigate compare with the tag ID that satisfies N1. Similarly, same server investigate the compare with the reader ID that satisfies N2. So in the server have to execute so many hash operations M plus N plus 2 by 2. So averagely. So it is evident that computational cost is linear with the number of readers and tags in the system. So this scheme is lack of scalability. Discussions in this one. So we have first reviewed the recently proposed protocol and we have executed their protocol is not scalable. And we have shown that their scheme is vulnerable to the tag information and the parallel session attack, thus that their scheme is failed to prevent the non-session specific temporary information attack. And we aim to design a new and more secure authentication protocol for using the elliptic cryptography for telecare medicine information system withstand the following found in the Jodal scheme. And this one is the reference of my paper. Thank you.
This is also a review paper.
Yes. Outline of my papers.
You have not defined any problem.
Sir.
Have you not thought of doing any work to implement partially from this?
Next one, I'm going to design a new protocol, sir, which is based on the elliptical cryptography for the telemedicare information system. Sir.
So, if any,
sir,
we are using the word improved.
Sir.
Improved RFI. So, what is the improvement?
Improvements in this, there is a lot of attacks, sir. One is the non-session specific attack and scalability and tag impersonation attack. Sir. Sir, in the existing protocol, there is a security issue, sir. Three attacks are there. So that's why I found that protocol. In future, I will design new protocol based on the elliptical system. For that is telemedical and information systems. Yes, sir. Yes. Automatically train will stop some distance. Yes, sir. No, sir. In that, there are a lot of security issues, sir. Yes, that's why we have designed a new protocol, sir.
Whether you are focusing on any man in the middle attack,
Sir?
man in the middle attack.
Man in the middle attack. So that is a regular attack, sir. This is one new attack, sir. Non-session specific information attack. This one is a new attack. So that is the already regular attacks. So every designer can, in mind, they have definitely, he can design without attack, man in the middleman attack. Thank you, sir.
So if there is no questions, you can welcome paper ID 7874. Name is Sachidananda Deuri. First name Sachidananda Deuri. 7874. Okay. Absent. Then you can call Abhiral Jain.
A very good afternoon to all the dignitaries, all the fellow researchers and authors present here, and the fellow audience. I am Hitesh Daga, a third-year student from Vellore Institute of Technology. I'm pursuing information technology, and this is one of my research papers which was co-authored by my fellow teammates Aviral Jain, Vidip Khetriwal. It was done under the supervision of my professor, B.K. Tripathi, sir. Yeah. So let's start with a quote. The one who cares will place the planet before anything else, will choose to keep clean, to be clean, and most importantly, promote cleanliness. As you just saw, the title of my paper was Smart Garbage Classification. What we're trying to do here is implement a new model which will answer all the needs of recycling, will make the world a much more cleaner place and a better place. But this is just a starting model. It needs to be refined more. It needs to be more polished. Yeah, so let me start with the introduction. As I said, that we have, just a second. Is this not working? All right. Recycling is quickly gaining traction nowadays, and recycling is mainly a problem because when we talk about recycling, there is some hidden cost that is there when it comes to processing, when it comes to selection, when it comes to classification, and our model is trying to evolve on that. What we have done here is taken a basic garbage can and segregated it into different compartments, and we have attached a camera on top. On the basis of the garbage, it will be scanned and a compartment will open and the garbage will automatically drop into that compartment. The main problem that we're trying to address here is that in today's society, most of the people don't know about the different kinds of wastes that are there, and they don't know which waste should fall into which category or which bin. Basically, we have three different kinds of wastes: biodegradable, non-biodegradable, and the others category. That is the reason why we have green, blue, and yellow dustbins. But most of the people don't know that. We have used CNN, machine learning, and AI to implement on this problem. This is the basic overview of our model. Firstly, the garbage is thrown. A camera then captures the image. The image is passed into a convolutional neural network. The image is processed and is classified to one of the categories. The gate for the appropriate dustbin opens. There'll be a slider which will push the waste into that particular bin. The arms move to push the garbage into the hole. The component and the modules used are mainly the hardware and the software component. The hardware component has an integrated Raspberry Pi controller. Now, a Raspberry Pi is nothing but it's used for capturing HD pictures and HD videos. In our case, it would be the HD picture, so that whichever garbage is being scanned, it's done in an HD format. And we have robotic arms which will push the respective garbage into the particular component. In the software component, we have the deep neural network that we'll be using. It's efficient B0, which is a CNN, which will classify the image, which will recognize the image, the class which it belongs to, whether it's a metal or plastic or another kind of garbage. And the Raspberry Pi module, which sort of binds both the hardware and software components together. The algorithm is, first the data is collected and it is done for waste classification. The practical imbalance data is then processed and resampled. We get away from all the oversampling and underfittings. Then we follow up with augmentation, standardization, pre-processing is done on the data set. The image data generator class at very epoch ensures the model gets fresh iterations of the images. Post completion of pre-processing, the training of the model is done. Transfer learning principles are implemented. Also, optimizers are used. Here, transfer learning, as we know, is something which is very common nowadays in ML. We take a base model and we implement a new model on that. The base model which we have used here consists of over 1 million images of different kinds of wastes that are there. Not only waste, different kinds of objects. But for us, we needed a new model which has separately the waste that we put into our bins. So that's why we chose 12 classes specifically out of all of those millions. And that was helped by the image generator class, the image data generator class. Early stopping is also used and validation loss is monitored with a specific patient's level or value. The data set we have used is available publicly on Kaggle. It has, as I said, 15,150 images, and we have taken 12 different classes. This data set already had the training data set implemented on it, which made it easy for us to use. And as you can see, the different kinds of garbage that are there: paper, cardboard, biological, metal, plastic, green glass, brown glass, just to name a few. And these are some sample images that we have incorporated here. Let's start with the model training. After all the pre-processing is done, the image is passed into the network and the model is trained. The concept of transfer learning, as I said, is used here. Basically, what we are trying to do, as well as besides doing transfer learning, is going for optimization. And for optimization, we've specifically chosen one special optimizer, as I've mentioned. It's ADAM optimizer. ADAM is adaptive machine optimizer, which basically helps in refining the image quality, and CNN basically has many features in that, which is incorporated in the ADAM optimizer, which I'll come to at a later point. Finally, we have the results and analysis. An accuracy of 99% was achieved on training data set, 92% on validation data set, and 93% on the testing data set. As I said, the use of efficient net B0 and ADAM optimizer helped us in gaining this accuracy. We can see a classification report with the precision, recall, F1 score, and the support of all the different kinds of categories of waste that we have. Mainly, we have taken these 12 subclasses, and there might be one or two different kinds of waste which might have a similar F1 score or a similar recall just because they look alike. That is one thing that we have to get ahead of. Next, this is the screenshots of the output that we got from the code, which we executed using Python and the IDE. The item detected is scanned using the camera. This is what will happen with the camera that you see in our 3D model that I designed using Blender. There is a camera and a particular waste is being dropped into the bin. Instead of having those hinges, I attached two cards which will push the garbage into the particular slot or the particular compartment in which it should fall to. So in this case, it should fall to the blue category because it's biodegradable. The future scope. Our proposed model will help people who are not aware of different kinds of waste that are there. It will help with easy and quick segregation of waste. You just drop the waste. You don't have to bother about what kind it is or how it will impact the environment. The bin can be a recycled one as well. The entire process is automated, so there need not be any human intervention. The future is basically for an impactful tomorrow and a cleaner earth. So as I said, this paper mainly focuses on how to segregate waste and differentiate it to different kinds. We have segregated 12 different kinds. We have used neural network. And this is a very small data set, but this can be implemented on a huge scale. We can implement it on a big data scale. But since it was just at its very nascent stage, we did so. The important references. And finally, I would like to thank my teammates, Aviral Jain, Vidit Khetriwal, and Sir Professor Balakrishna Tripathi, sir. Without his guidance, this project wouldn't have been possible. Thank you so much. I would like to have some queries. More than queries, I would like to have suggestions because I'm just a student and I'm here for learning. So if you could help me iterate this model a lot more so that it could be refined, it would be very helpful. Thank you.
Presentation. You are studying BTech third year?
Yes, sir.
Computer science?
IT, yes, sir.
IT.
Yeah.
Okay, IT, computer science,
yes,
many relations are there. So the topic is interesting and you have done a very nice work. But my question will be, have you started implementing something in reality or just simulation classification using the algorithms? Have you started implementing something?
Yes, sir. Basically, we are thinking about getting this patented. We are thinking we should start making this model in reality. This could like change the scope for garbage in a very big different way. Like we have compartments here. The lower lid could also open and there could be a bigger place where it could all be composted on so that, you know, this
idea is no doubt very nice.
Yes, sir.
But you start implementing, try to produce a prototype.
Yes, sir.
Once the prototype is successful, then you can approach for further.
Okay.
Topic is interesting.
Yes, yes.
And I will rather, it is good that being a BTech third year students, you have taken up a very important project.
Yeah, thank you. Thank you.
And try to convert this problem into research. Because there is research component is almost nothing.
Yes, yes.
It is rather a project-based work.
Yes, sir.
So you can start doing the project and try to improve that project to research side.
All right.
That will be my advice. Huh?
All right.
Okay. And go for higher studies after BTech.
Yes.
Instead of going after jobs.
Thank you, sir. Yeah.
Yeah, nice talk, good talk. You showed some table, some results.
Yes. Sir, excuse me.
The table you showed.
Yes, sir. This one. Yes, sir. Yes, sir. After implementing CNN, we got all of these results. Yeah.
The point is an image of garbage.
Yes, sir.
Garbage may be a heap of garbage. So you don't know what is inside. Maybe seeing only the surface image.
Yes, sir. Yes, sir.
How do you take care of this? Things are hidden inside the garbage pile.
Yes, sir. So as I said that our project is at a very nascent stage, a beginning stage, but this is mainly for the common masses, people who are not aware. We usually throw things like, suppose I'm having a packet of chips or I'm having a Coca-Cola drink. I don't know where to throw it. If there are 3 different bins, if there is just one particular garbage, I got your question that there's a heap of garbage.
I mean, that's a problem which is a deeper problem of not having civic sense.
Yes, sir. Yes,
not having respect for other people's rights.
Yes, yes.
That's why the traffic violations and everything.
Yes. Okay, thank you so much, sir.
One question.
Have you done any comparative analysis? Because this kind of model do exist. If you will search, there is a model named WASNet. So they do the similar kind of things which you have done, because you have claimed an accuracy of 99%. So is there any comparative analysis that if you move forward with the patent part, then you have a better edge over the other existing models or previously existing models?
Yeah. So as you stated, there is a kind of model that is there, but it's not just as similar as we have here. They don't have that compartment thing that we have incorporated. Along with that, we have used Adam Optimizer. It's very fast, it's very efficient, and it will give quick results. So the camera won't take that much time to scan the waste, and there won't be that much time taken to open the respective compartment in which the waste will fall. So in terms of time and in terms of design, this is a very unique thing that stands out there in the market. So I think, yeah, it could be patented and it could become a very big thing in the future. It's just a small idea for now. Any more questions? Thank you so much, sir.
Very nice deliveries. Now we are at the end of this technical session. I would like to request Professor Bisoi sir, our former faculty, MCA department, please come to the dais. We'll have a memento ceremony for our session chair and co-chair. We'll present memento to our session chair. And I will request our program chair member, Manas Ranjan sir. Sir, please come to the dais. Our session chair, Dr. P.M. Khillar, and Sir Bhoi, session co-chair. Convener, please join. We'll have a photo session. Bisoi sir, please present memento to Manas sir, please present memento to Khillar sir. So now we are at the end of technical session 5 and we'll break for lunch here. After lunch break, our technical session 6 will start. Lunch is ready, so we can, participants and expert members can proceed to dining hall. We are perfectly in time. Breaking for lunch as scheduled 2 p.m. Thank you. We can proceed for lunch.
सीधा कर उठे नहीं पुढे हाँ हाँ
And my co-authors are Mrs. Rajlakshmi Pari and Dr. Sanjit Kumar Das and Jibdesh Mishra. They are also from OUTR. So these are my agendas. We will discuss one by one. Next, introduction. Here, I am presenting my topic, satellite image classification. First, we have to need what is that? Why we are using satellite image nowadays? So, this is the one, if we see, satellite image classification is the most significant technique used in remote sensing. So, if we ask about remote sensing, it means is a process to identify, to connect the satellite image, the satellite with the reflection radiation of an area. Those who are covering from satellite, we are taking that image. And next one is, I am here using classification. Classification means I am doing classification using several things, like here we are using feature selection, extraction, and object color, texture, background noise, rotation, and scale environment using varieties of methods. What are they? We'll discuss later. And this is my motivation. If we see in our daily life, we are using what? Satellite image for what? We are classifying the satellite image. It means satellite images, through the satellite images, we can control the natural disaster. Like we can capture the picture of air pollution and how we are getting the news. Nowadays, we are getting the news from news analysts. How? Because the satellite image capture all the things and collect all the things, we are getting landslides news. How? Because the image focusing on this satellite image, we got that news from the satellites. And if we see in our human eye is very weak, very less. Our human retina is very less to identify one picture. We are seeing one picture, one by one picture, but in this picture, we only see what are the picture. If we see one picture of cloud, we can't see the weather. We can detect the weather. For that, we have to classify that. So, for the classification system, we are using several things like CVIR and local binary pattern. And moving towards another. So, these are my objectives. In objective, I have mentioned how we can collect the nobility. We can connect the nobility with the satellite image classification. Means here my opinion is, if we are using satellite image, for that we are using some clarification. For clarification, you are using something like local binary pattern and CBIR, content based image retrieval. First, it collects the information and noise about the image, one pixel by pixel. How we present one image, whenever we are connecting one pixel, gathering pixel, then we can get any picture. For that only we are using CBIR. We are using here CBIR, content based image retrieval system, and local binary pattern. So these are the literature reviews I have mentioned here. In 2021, Pavitra LK Sri Samila is the title with texture image classification and retrieval using multi-resolution. In this paper, they are using Gaussian method. And in this second, content-based image retrieval using HSB, color space, means they are using HSB, hue saturation value, and means they are collecting the particular photo station, like coloring system, how they can connect with the feature like color space feature, color texture, etc. And next, the machine learning paradigm towards content-based image retrieval on high-resolution satellite. Here, they are using SBM, we can say SBM model. This system learn the ensemble the methods, like if they are doing the texture selection or texture extraction, they are expanding this here. And last one is content based image retrieval using color feature only. Color feature silent region means they are extracting all the thing using the FCM method. FCM means fuzzy C means cluster. So this is my system model. Okay, if we see, my topic is like what? CVIR, content based image retrieval system. Okay, if we see what is CVIR first. CVIR means it collect the query images. Query images means the collection of the images, and then we first set query image from the database. We are collecting the database and we set that in query images. After that, we have to extract, and we have to extract their feature from this image only. Then we do the image pre-processing system, then blocked based CBI system. Then after that, we got final result, retrieval images. What is color feature extraction? I say now, color feature extraction I am using from CBIR. Whenever we will see in a picture, we are seeing the picture. If the thing is high, the high resolution means if we see one picture, in their picture from some of side are highlighting, or some sides are in the sense of gray or black and white, like this. So we have to use some method in it to classify that, more clarify it. And we extract the color feature from channel and merge them, means we are using CVIR method here. And plus local binary pattern. Local binary pattern, what is this? Local binary pattern means if we collect one picture from satellite, first we have to choose whenever my picture is satisfying for this classification or not, whether it is higher pixel or whether it is lower pixel. For that, first it count the neighbor radius. If I was standing here, if we see different kind of particles, different kind of pixel around me, okay, after that we can collect with, if I am standing here in left, we can connect with the top and bottom and right. Exactly like that, LBP is connecting with the center pixel value with the neighbor pixel value. Whenever we got the center pixel value is lesser than the neighbor pixel value, then we'll counting that in 1. Means that highlighted part we have to reduce. And if we got 1 greater than 0, then we have to remove that part. Okay, fine. Next one is image pre-processing. Here we are doing image processing used to improve the quality. If we see improvement of the quality, like if we are using one picture, we are using one data set. Okay, in that data set, we are connecting some query images, one by one query images, setting 1, 2, 3, 4 like this. After that, we have to put different kind of method, like FCM we are using, SBM we are using, but in our system we are extracting, you are adding some extra thing like LBP plus Gabor filter. And and next one is blocked based CBR. It is a retrieval system, means unwanted pixel they retrieval. Means if we see one picture, if they are any unwanted, means if we are capturing some photos, Okay, then from their image, the unwanted part is this is not necessary for this is not connecting us for any any useful information. For that, we have to retry that. Means we have to first we have to choose which one is the better, like using this LBP method. Then we have to discard this. Next is database. This database we are collecting from the Google Earth 2, and this is a running database. If you search now also, you can get this database, but different area you have to capture by one by yourself only. And we are taking only here 50, but in the result section we are using first 50 we are doing for the sample test and 600 for the whole system test, and we are using all airport and forest and parking here for high resolution image. And next is high pixel intensity. Though I see what is the high pixel intensity. First we are this is my input image. First I am using this input image from satellite. That means for the classification, first we have to check the quality of the pixel. If the quality of pixel is not better, then we have to extract that. We have to give some gray label code, gray label GLCA, gray label. Like if we intend our intensity value is pixel, like if we have to check single pixel value, means we can say here. After that it is like a square pattern, means they are selecting one single pixel values. Sorry. And after that, for that image also we are putting this FCM, means fuzzy C-mean, means it check the robustness of the image. This image is perfect for highlighting or not. After that, it's combined with the local binary pattern, means FCM is added with the local binary pattern. Local binary pattern's job is giving the better pixel to us, and FCM is if whether the radius of the picture is correct or not. It giving it to the GB green, blue, and R red method. Okay, fine. Sir? Yes, sir. Okay. Next, this one, our output for visualizing LBP plus Glaber. We are using only one picture here, and for the in the first section we can see overcome the drawback of losing information after Gobert transformation downsampling. If we are using first FCM method, that is better, but when you are using LBP plus Gabor filter, they are getting the more easiest, more clarifying image. We can remove the highlighted part, we can adjust for human eye, we can see smoothly. And next is so this is our result part. Like if though I said we are using 600 picture inside it, first we have to compare with all whether our LBP algorithm is adjusting it or not. For that we are taking the 180. Sorry, what happened? So we are using here 180 comparison, taking here 50 samples for the testing only and 600 for the whole database query images in one loop. After that, we got the 71% of pictures are successful retrieved, means which those pictures are highlighted, we are converting into low level image. Like we can catch the image anywhere through by without giving any harmness to our eye. And Next is conclusion. Though I said we are using the highlighted image for the satellite highlighted image for high resolution to low resolution we are converting. So we are using here LBP and Gaber method. And in future we are seeing in future we can add this FWP LVP like fractal weighted and we can arrange this like with the extra features. So this is my future work. Here we are though I said for developing application, web application means we need not to mention any filter by using it's like we are doing MATLAB code, we are doing Python code, but whenever the application develop, we can put their image. Image may be your whole database like 3 lakh 4 lakh, that capability we are looking for this. And these are my references, and thank you.
Any query from audiences? Audience?
Can you explain what is color histogram? You have mentioned in the methodology.
Audible? Hello. It means when we are using histogram, okay, it means it construct the picture. Means if we see the lower part of the image, means it is a gray or black label. Okay, we can, if we are seeing means we can see, if we can see the black and white picture, then after that we are adding some feature like FCM. Though I said we use the FCM and all Gaber filter to and RGB and HSB format for extracting the feature, for clarifying the feature, for betterness the feature, means we can see in our naked eye.
What methods? What methods you have used in the image pre-processing?
Image pre-processing, we are using only CBIR for CBIR method plus Gaber filter. Means CBIR.
What kind of noise? What kind of noise it can?
Gaussian noise. Gaussian noise. Yeah. Thank you.
In your future work,
yes, sir.
Just go to that.
Yes, sir.
You want to innovate a new feature selection method for better classification. What exactly better?
Sir, better classification is means I am studying now. I am also writing some journal paper. Okay, in this I mentioned that if you see the history, you can see only in satellite image history, you can see only FD is there, fractal descriptor is there, local binary pattern is there. But I am merging this for the first time. For that only I have mentioned that, for better clarification.
Thank you.
Okay, thank you so much, sir. Thank you all.
Thank you for your presentation.
Thank you, sir.
You're doing PhD?
No, sir. I am thinking for that. I'm thinking for that. For next year, I will do.
You are in masters right now?
No. Completed, sir. Now I am doing job assistant professor.
Okay, you are faculty there.
Yes, sir.
Good.
Yeah.
So this particular work that you have shown.
Yes, sir.
Could you go to the result one where you have the graph?
Okay, sir.
Slide number 14. Yes.
Yes, sir.
So here you have used this LBP plus
Gaber filter.
plus HSB you have shown and LBP plus Gabor filter.
Yes.
Why you haven't taken the result for that, the hybrid version of it? You have taken the result for Gabor and LBP alone.
Yes, sir.
And in the previous slide that you have shown, you go to the previous slide.
Plus,
here you have shown here that you got that particular image
yes.
From these by using these two.
Yes, sir. When I am using this LBP plus Gabor, okay, means we are if we are adding some particle like LBP is collecting the neighbor features like radius around them, pixel they are connecting, and Gabor what is doing it is connected with the CBR only. CBR means it will retrieve the image from one to another. And next, we are comparing two things. If Gabor filter is showing this much, LBP is showing this much, means this is, if we add this, also we can get the same answer.
Okay, I got it. Thank you very much.
Thank
and
you,
all
sir.
the best for your future work.
Thank you so much, sir. Thank you all.
Okay, now the next is paper number 2265. So before you start, we have only 7 to 10 minutes to complete. So please concise on that.
Okay. So good afternoon to one and all. Myself Om Prakash Jana, Assistant Professor, Department of Computer Science, University. So what exactly in current scenario, any type of review comment play an important role for any taking decision. If you may go for any type of e-commerce site, any type of websites, any type of product based any company, they are basically focused on the review report over there. So here in this work, we have elaborated how we can implement our sentiment, that is the sentiment analysis for the movie review data by using Ansible machine learning method. What exactly Ansible method is there? Different methods are there. We have to combine those methods and taking the best possible combinations by any type of majority assessment, whether it may be a voting method, it may be any type of other approaches for the Ansible method. So this is the workflow of the entire work. As usual, it is the abstract, introduction, related work, your purpose methodology, performance measurement, result analysis, and finally is the conclusion and future work. So this is the overall idea. And in the sentiment analysis, it is coming under the one category of the natural language processing problems. What exactly you can call that as a NLP? Simple thing is that to understand the language of a human, to analyze that one, to predict in some better way, the NLP play an important role. And with the merging of machine learning, artificial intelligence, NLP, by using NLP, you can solve several type of a critical aspect problem in very simple, easier way. So here we have taken the most famous database, IDMB database for the movie report. Different type of machine learning algorithms are here. Where normally here we go for the machine learning, not the deep learning over there. So several machine learning method we have used. We have used the Bayesian machine learning, logistic regression, random forest, support vector machine, and also we have taken the stochastic gradient model, multinomial Bayesian, etc. Finally, we merge all those models to find out the ensemble model by using voting majority aspects. By using that voting majority technique with the different type of features such as positive review and negative review, we have found that basically the optimistic result than the normal machine learning models. So the ensemble will provide a better accuracy than the individual ones. So those are the methods we have adopted over there: Bayes, logistic regression, random forest, multinomial Bayes, stochastic gradient were taken. We have taken the majority voting, movie review, and so no need to describe those things over there. I'll directly go for these are the recent works. Several works has been reported by using SBM RN with a different type of accuracy. Now that one is the basic proposed methodology. Initially, we have to start at the data collection. Then it will go for the different type of pre-processing. I'll not elaborate that pre-processing. Normally, it is coming under the sentence detection, tokenization, lemmatization, stemming, and the other aspect are there like your word embedding, how to convert that your text into the form of a vectors, numeric value. All other will be coming under that pre-processing. Once the pre-processing is done, then we'll go for the separation of a training and a testing. Maximum number of work what we have covered, it is coming under they are divided into the data set into the training and testing data set, then they perform the pre-processing. But what we have implemented over here, first we have to go for the pre-processing, then we'll go for the dividing, so that it increase the accuracy of the data. Unwanted data are not go for the training as well as in the testing. What will be the issue over there? If I have to noisy data, it can be filtered after the pre-processing. If it is before you have to go for the splitting, then there is a issue for the accuracy over there. Once the data sheet is ready, then it will go for the separation of normally we have separated 80-20 ratio over there. Then finally it will be ensemble classifier, voting majority will be calculated, and the evaluation of the model by using different accuracy model. Like we have taken the confusion matrix, we have taken the precision, recall, voting methods, and finally F1 score, and final prediction will be there. So these steps are associated with the pre-processing steps. All of you know those concepts over there: tokenization, lemmatization, stemming. Lemmatization, stemming, there is always confusion regarding the research of that. Both are same. It is exactly not same. If I say lemmatization, I can deduct some of the words till the meaning will be there. But if it is stemming, so finding the root word is called as that stemming. So stemming is the root word, but if it is a lemmatization, it is based on the context of that. In which context that word will be represented, that is associated with the lemmatization. Then we'll go for a part of speech tagging, like you have to find out the noun, verbs, adjective, adverbs, etc. Then stop word identification, and always the condition is over there. I have to convert all the data set into one form. Either you have to go for uppercase or you have to go for the lowercase. There is no combination of. If suppose, let us consider one example. I have started from a one upper character and next are small character. The model will recognize this one is a one word. Similarly, all small letter, another word. All capital letter, another word. So to avoid actually there will be only one word. Like suppose I said that is a tree. So if the first capital letter equal to T, then all are small, it can be one word. Then first one is small, then R is capital, other are small is another word. So there is a confusion on the model that it will define different number of word, but actually they are one. For that one, we have used that conversion of a lowercase to uppercase like this. Then the most important feature is that it's a vectorization. So two type of vectorization method we have used. One is bag of word, another one is TF-IDF. So out of this, TF-IDF give the better accuracy. That's why in our model, we have used the TF-IDF model instead of bag of word. Finally, we go for the NER, name entity recognition, and word embedding methods. So these are the algorithm we have used, Bayesian algorithm, with that G is defined the number of features or feature over feature space over there. which is the sentiment analysis, and we get basically we taken two. One is a positive review, another one is a negative review. Random forest classifier. Then we have used the support vector machine with the help of the support vector maximum margin. Whatever the maximum margin will be there, we have to minimize that one to find out the support vectors. Finally, the performance parameter can be calculated by different aspects. First, we developed we have calculated the confusion matrix, then precision, recall, F1 score. All those values will be calculated by those formulas. And normally, if you check, the data set of IDM will consist of 50,000 of records. The 25 is around that positive, and the next 25,000 is around the negative report. But we have combined all those with some partial modification, make that data set is more robust, like 1,50,000 multiplied by the 3 number of value over there. Again, I calculated the precision, recall, and other score with the respective different number of a classifier. Finally, we apply our proposed model to get up to a 94% of accuracy, which is far better than the other individual accuracy. So, which type of features we have taken? We have taken the lexical features like positive word count, negative word count, connotation of positive, connotation of negative, and with a different number of along with the other features over there. Now, to reduce the feature, we cannot manually reduce the feature. For reducing the feature, several feature techniques, reduction feature technique we have taken, like simply calculating the information gain, calculating the correlation among the features, chi-square value, and we found that the RLPI, regularized localized preserving, will give a better feature selection than the other method. Why? It will only select the discriminating features. It will avoid the similarity feature. It will only find out the discriminating features. So by applying this RLPI, we get a higher accuracy. That's why we have taken the RLPI method for the feature selection. And this accuracy we get, and overall we get a 94% of accuracy in our proposed method with the voting approaches. So these are the some of the skins we get the output by using word cloud. After applying the word cloud, we get some of the positive words as well as some negative words. And if you add those things, it will be indicate the significance, whether it is going for positive review, whether it will go for a negative review by analyzing the word. Similarly, this one is for the negative review words over there. Finally, what is the conclusion? We get those amount of accuracy in normal machine learning model. Once it is reassembled, it will go to a 94% of accuracy. We have applied the word cloud. I have already described that one. We have applied the word cloud for the finding the positive word as well as for the negative word with the estimation of the model. So this can be very helpful in marketing, advertisement, and other type of promoting a devices, promoting an item, promoting a movie, analyzing a movie, and other things over there. So one thing we can focus in the future for optimizing the ensemble methods. I have to normally take in the machine learning model here. We have to formally check whether I can apply, since the data set is large, can I apply the deep learning method over there? And again with the other approaching the ensemble method for a superior recognition system or recounter systems. So these are the references we have used. Okay, any question?
Any queries from the audience?
We were talking about the data set that we used for the movie reviews.
Yeah.
So which data set you have used?
We have used the RDMB data set. It is widely open. You can get from any website. You can get from the Kaggle also. So it is open. You can easily access.
Because you showed one movie review data set. You have took ID, MB.
Yeah.
I think that has been misinterpreted. I think it is IMDb.
IMDb. You are saying that it is IMDb?
Yeah.
Or maybe. Okay. So that data set, it will consist of that review report. Review report is mostly used on that data set. Yeah, fine.
Any other queries? Okay, so I have one query. like you have taken so much step in the pre-processing step, right? You have shown like. So do we have some method that you have realized that you can reduce the number of steps of pre-processings
Yeah.
that you have shown there, so that the accuracy will be the same and your computation time can get reduced?
Okay. So what exactly we have to do? At a time, we have not go for the 10 and test data. First, we have to go for the pre-processing. Then the data, once the data set is ready, it will go for the testing. First thing. Second thing is that I can overcome those pre-processing steps like sentence detection is I can overlap. I can combine the lemma and stemming into one word. It will be fruitful noise. So third thing is that you can, if the meaning is really understandable, there is no concept of guiding that number of words over there. So at that case, you can also remove that stop word identification or like this extra punctuation symbol, extra character over there. Even if NER is not also needed, if you go for the optimization concept. So we can only focus on those parts which is associated with the our needed data.
Thank you so much, and thank you so much for your presentation.
Okay,
and
fine.
all the best.
Yeah.
Next is paper ID 2770.
Good afternoon, one and all. Good afternoon, delegates and my dear friends. So today, my paper presentation is on application of efficient feature selection and machine learning algorithm in mental health disorder identification. So coming to this topic, we are going to discuss about the introduction, objective, then the proposed method, mathematical modeling, result, and the conclusion.
Ma'am, sorry to disturb. We have 7 to 10 minutes to present.
Yes, sir.
Thank you.
So coming to the introduction part, generally mental illness, mental health, which is one of the subject and given to the least priority in the workplace and the society. But it affects a lot whenever the person is not psychologically or suffering from mental illness. At that point of time, well-being and productivity level of the people decrease. And the mental illness which causes unusual and the dramatic shift, moods, energy, hallucination, lack of motivation, loss of interest, and inability to think any particular topic. And most of the population with different technical employees are likely suffering from mental disorder. So here we have used different kinds of machine learning algorithms, and before implementing the machine learning algorithm, we have implemented different feature selection techniques. So here the complete data set, which is consist of 61 attributes and 1250 rows, then we have used different feature selection technique. After selecting the features which are most required and which are most preferable, only on those features we have implemented around different 7 machine learning algorithms. Then we have checked the performance for the different machine learning algorithms. So coming to this objective, here the objective is to predict the mental disorder prediction using various feature selection algorithm for a specific data set, which we have taken here as technical survey data set, OSMI data set, which is open source mental illness data set available in the Kaggle, and these results, whatever results we got, based on these results, we can conclude that like in the industry, we can narrow down this approach of reducing this mental illness and create much comfortable workplace for the employees to work. Here, first we have to identify the major attributes towards mental health illness. So in order to find out the attributes which are more more preferable or more affecting towards the technical mental illness, before to that, here we have implemented the pre-processing technique. So after pre-processing technique, here one of the method which we have used, the data exploration, where we have done the analysis of the data, and then we have explored the data, which features are more correlated with each other. As per that, we have dropped down the features which are more correlated based on the heat map. Next, the proposed method here, what I have used is the mathematical model. So in this mathematical model, here I have considered n different universal features which are represented with capital N, and the different feature selection technique which I have used here, F1, F2, and F3. So basically, the F1 are the set of features which we have extracted by using lasso feature selection technique. And the F2 is the set of features which we have extracted by using RFE-CV, one of the feature selection technique. And the third one, which is F3, is the another feature selection technique which we have implemented, and where we got around 10 features after implementing RFE feature selection technique. Next, by using all these three feature selection technique, I have represented the three feature selection technique, where small f is the different features and the attributes which we have taken from the OSMI dataset, and F2, F3, and F1 are the different feature selection technique which we have extracted by using lasso, RFE-CV, and RFE. Then what I have done here, these are the features which I have extracted by using lasso feature selection. So here I got 19 features out of 61 attributes. Then I have implemented RFE feature selection, where I have extracted 14 features. And the third one is recursive feature elimination, where I have implemented, I got around 10 features out of 61 features. Then on those, again, I have implemented this associative property of union, where I have done the union operation for on the three feature selection technique, lasso, RFE-CV, and the third one is your RFE. And at the same time, I have implemented the associative property of intersection, where I have used the same three different feature set, which I have extracted by using RFE, RFE-CV, and the lasso. And the distributive property also implemented on those same three different set of features, which I have extracted by using RFE, RFE-CV, and the lasso. After that, I have implemented different machine learning techniques like SVM, naive Bayes, stochastic gradient descent, KNN, decision tree, random forest, logistic regression, gradient boost, cross gradient boost on the selected features which I have got from lasso, RFE-CV, and RFE-CV. Then here is the result which I have after implementation of all the machine learning algorithms. These are the accuracy scores which I got, and the recall score at the same time, the precision score also calculated on the complete 51 features. After the data processing, I have extracted only 51. So on those 51 features, I have implemented all these different kinds of machine learning algorithm. At the same time, so here is my data set. So only one part only I have shown you because space is not there. So then I have implemented the lasso, RFE-CV, then the union operation, associativity, intersection, distributive property also implemented, and these are the results which I got after implementing different machine learning algorithms on the selected features. So here what I got, the accuracy of the lasso feature selection with cross gradient boost random forest, where I scored 79% of accuracy. And at the same time, RFE, whenever I have implemented here on the RFE feature selection, on those features, here also I got on the cross gradient boost, the accuracy which is 79%. And the third one also in the RFE-CV, recursive feature elimination with cross validation, where I got the accuracy of 79%. So here it is concluded that in almost all the 4 cases, I got 79% of accuracy on the feature selection when I'm taking the selection method with the random forest gradient boost. There only in every case, almost in every case, I got this much accuracy. So here the conclusion is that the classification algorithm is evaluated for the better accuracy with the cross gradient boosting. In almost every cases, the cross gradient boost is giving the better accuracy with random with lasso, with RFE-CV, and with RFE-CV at the same time with the associativity property as well as in the distributive property. So here what is the conclusion that the prediction for mental health illness in the technical survey data set for technical people compared to non-technical people is 79%. So these are few of the reference.
Okay, thank you so much, ma'am, for concluding your work in 10 minutes of time. So thank you so much for that. Do we have any queries from the audiences?
Ma'am, what is the difference between RFE and RFE-CB that you mentioned in the analysis part?
Yes. Here, I have used RFE-CV, recursive feature elimination with cross validation, where it will, on the complete data set, it will recursively take few data set, then it will implement the cross validation on those samples, then retrieve the result, which is happening in case of your recursive feature elimination with cross validation. Whereas the other one, which is called as RFE only, where it will recursively takes the sample, right? It won't without implementation of the cross validation. I got the 10 features based on the score. So recursively it is taking the samples, then it is implementing all the 7 different machine learning algorithms.
Any other query? Okay. So, ma'am, I have one query. Like in slide number 18, I think there is typo, something mistake I find out. 88, I think. Slide number 8.
8, sir?
Yeah. Here, I think the first one is
F1.
Okay. And the second one is F2, and the third one is F3. It is okay.
Yes,
Now, ma'am, my second query is, like, we have done the feature selection. So from 61, we have down to 10.
10 in case of RFE.
Yes. So let's say in case of RFE, if we are taking 10 features, so your whole dimension of data will be 10 into 1250.
Yes, sir.
Right? And from there, you are getting the accuracy of 79%.
Yes, sir.
Right?
Yes.
Now, I think you have mentioned like 51 feature you have used for that.
The 51 features I got after implementing pre-processing.
Pre-process.
Yes.
Okay, thank you. Thank you very much for your presentation, ma'am. And all the best. Now we have the last paper of this particular session is 8489.
Good afternoon to all. Myself Pritimai Satpathy from Department of Computer Science and Applications, Utkal University. In this research, I used feature reduction method of machine learning approach for improving the intrusion detection system. This is my presentation outline. Before starting my presentation, I would like to give you some introduction.
Ma'am, again,
Should I
7 to
skip?
10 minutes.
Should I-
You just go to your problem
Analysis.
statement
Okay, sir.
and then propose work. That would be better.
This is the related work I have followed. This is my objective. Based on the literature review I have done, there are some limitations on the literature review. In most of the cases followed either one or two methods of feature reduction method, or in some cases they did not follow the statistical model like AIC comparison. In any of the cases I have studied, my objective is that I using implementation n ratio and chi-square methods to get the optimal feature set. Then then proposed a new hybrid feature selection method using the mathematical set theory intersection that gives the minimum feature set that is required in an IDA system ecosystem that reduces the false positive rate, which is also known as the false alarm rate. Then comparison and analysis using the 5 machine learning algorithm: RF-tree, LogiBoost, J48, net bias, and BiasNet on benchmarking IDS dataset. Then evaluate the model using AIC. That is a statistical model using to comparison the model. And to evaluate my proposed model, I also comparison my analysis with 4 published papers. This is the data set I used in my research. One of the most well-known benchmarking IDS data set, NSL-KDD. This is the methodology I followed. First, I pre-processing the data set using one-hot encoding. Then, after the one-hot encoding, I reduce the feature using the 3 feature reduction algorithm: infogain, gain ratio, and chi-square. After that, I using the intersection of 3 feature reduction algorithm. Then I use the classifier, and then using the then and evaluate the model using the following evaluation matrices. These are the following performance matrices I used in my researches: sensitivity, specificity, accuracy, precision, recall, F measure, MCC, RMC, RMC, AIC. Based on the confusion matrix I got from the 160 model. The 160 model I got, that is, I removed last 10 attributes. The methodology I followed, that the lowest 10 attribute I consequently filter out after last 10. I'll remove last 10, 20, 30, 40, 60, 70, up to 80 attributes I removed until I get the minimum features and good accuracy with minimum building time. That's this process I made three 24 data set. In the same way, I also made 8 data set of my own. That is the hybrid feature selection method I proposed. In this way, I 32 data sets with 5 classifier. There are 32 into 5, 160 models I trained. Out of the 160 models, I mentioned it is not possible to mention all the 160 model in the slide. So I so only the results of the high base classifier of each model in the slide. And it show that lower the AIC value, higher will be the accuracy. That is the 99.85. And that is only 41 features out of 121 features. That gives us by the chi-square method. And also our proposed hybrid method also gives good result. That is our hybrid method. 81 features on biasnet. That is, it gives 97.07 accuracy, which AIC value is minus 4.457952. I also analysis the model without any feature reduction method. This is the result. Whether feature reduction will improve the accuracy or not. That's why I analysis without feature reduction also. This is the accuracy of 41 attributes after removing 80 attributes. This is the accuracy of 111 attributes after removing lower 10 attributes. This is my comparison with 4 published work. But our proposed model give 99.85 point accuracy with only 41 features using the CS that is chi-square at feature selection method. While the Redford model gives 99.7% accuracy. This is my future scope. The proposed method can be used on multiple datasets with more feature reduction algorithm. A broad range of statistical matrices can be utilized to further assess the models. My future plan is also to build a predicting model which help new researchers to analysis their large IoT traffic data. Also, in this particular research, I apply only machine learning algorithm. My future plan will also apply like deep learning algorithm, all deep neural network, activation functions, and all these things. These are the reference I followed. Thank you.
Thank you very much. Do we have any query from the audiences? Okay. So I have you identified any application where you can use this technique of feature reduction and all?
Sir, feature reduction, sir, I analysis this in
Any application?
Sir, I analysis all this in Utkal and Python.
Application, ma'am.
Applications, sir, no.
We can go for health or some sort of image or any IoT security. Any application have you identified?
Sir, applications, sir, only, sir, I work on IDS dataset, benchmarking dataset. IDS benchmarking dataset.
Okay. One more thing is you have shown so many matrices.
Yes, sir,
right?
sir, I analysis all these things.
Yeah. So could you tell me the difference between accuracy and precision?
Yes, sir. Accuracy, precision, sir, sometimes accuracy, when the data is not balanced, that is, sometimes the data is unbalanced. Accuracy did not show the the model, so did not show the model is perfect or not. In that time, precision. So the precision showed the positive, which is actually positive. That is the true positive by true positive. By using the confusion matrix, there is a term that is true positive. In intrusion detection case, true positive means the the instance is actually attack and the IDS detect each attack. That is true positive. Precision formula is true positive divided by true positive plus true negative. That is the formula of precision.
Thank you. Thank you so much for your presentation and all the best for your future research.
Madam, here how you have related with the previous work?
I have analyzed
your data set. So how you have compared with the existing
I
work?
analyzed my analysis with 4 published work. Already for these are two journal papers and two conference paper. 2 are ACI indexing journal paper.
Thank you, ma'am. Thank you.
Yes, NSL KDD. Only difference is that they are using the different algorithm. all different feature reduction algorithm. Data set is same.
So with this, we have completed our all the technical sessions, all the participations, and now I will request Behra sir, please do the memento ceremony for our session chair. Our session chair is Dr. Suraj Sharma, Guru Ghasidas University. Sir, please come to the dais. Volunteer. Thank you, sir, for nicely conducting the session. Come. So now we'll move to our technical talk series. We'll have the 10th keynote address. And Sir Posan, as we have discussed, conferences bring industry and academia together. So all the series of keynote speeches were from academic professors. Now we have a person from industry, very reputed industry, Tata Consultancy Services. So we have among with us Mr. Prasant Panda. He is having 20 years of industry research experience. He has done his bachelor's from CET, Bhubaneswar, and his master's from IIT Mumbai. He has worked in different industries like Compton Grapes, R&D, General Motors, R&D, Synopsys, and presently working in TCS as a senior data scientist. He has worked in many technologies like power electronics, automotive electronics, static timing analysis, sign-off for VLSI designs. Presently, he is working in the research wing of Optumera retail product of TCS in the area of machine learning and AI. As we know, machine learning and AI is a core theme of our conference. So we are happy to have Mr. Prasant Kumar Panda as our keynote speaker. Additionally, he is inventor of 4 granted patents, and also he has many publications in reputed journals. So now over to Mr. Prasant. Sir, please, over to you. A very grand welcome to Prasant, sir. Thank you.
Good afternoon to all. Respected dignitaries, professors, participants, organizers committee. Thanks to all, special thanks to Mrutyunjay sir for giving me an opportunity to talk to all of you. Lots of technical activities already we have talked, we have listened also. We will not talk any technical activities here. What is going on in industry and what's the future perspective, we will be talking on that. So Before coming to the talk, I want to tell one small story. Many forums I have told this. One day, one person has gone to the doctor. Doctor has examined all his problems, habits, day-to-day activities. And after all investigations, doctor is saying, do the morning walk regularly. The person is saying, doctor, I am doing the morning walk every day. Doctor is saying, do it differently. Whatever the small story it is, but meaning of this is very significant. All these activities, what we have talked in these sessions and we are going to talk, already those things were existing previously, but we are doing it differently and smartly. So that is the whole activity on basis of which we will be talking on. These are the few industries in our day-to-day life we talk or we touch. Common person, they touch all these industries, one with another. Healthcare, retail, e-commerce, banking, finance, automobiles and defenses for nation. These are the few categories of the top industries we talk on. And these contributes a lots of, in terms of the revenue, in terms of the satisfactions for human being, in terms of activities in our day-to-day life for better future. Now talk about the healthcare industries. How the healthcare industry is going to do the paradigm shift. These are the few small important features, important things I have noted down, but there are lots of things. Many of times we are talking to the doctor for any disease. Doctor is looking everything and going saying that do the surgery. We don't have any option. There is no persons to validate that whether the surgery has to be done or not. And because of the business profit, because of few other activities, we go for the surgery. And after surgery, we see the difficulties what we face. Is there any system? There are many activities taking place in the world research, which are going to say that whether surgery is required or not. Central model activity, central modeling system is there. The data is retrieved and given to the modeling system. Modeling system says that yes, it has to be done or not. Of course, this is a very complex things. And since we talked about different technical things, model drift, data drift, all the features are technical activities are there. We need to overcome all these things. Diagnosis of the disease, whether it is infectious disease, cancer, etc. So we are going to predict it in a very proper way because of this paradigm shift in machine learning and AI features. Just I want to ask a question. If we want to go for the diagnosis of the disease, and particularly cancer is a various types of cancer. So which metrics we need to consider here? For example, we are going to predict the cancer. There are many metrics we talked on. So which matrix is more applicable here? Any guess? Dear students, any guess? The theme of this whole the things is related to machine learning and AI. Not exactly, but matching to that. So generally what happens, whenever we are going to any prediction of the system, particularly cancer, etc., we want false negative has to be reduced. There are two things, false positive, false negative. If it is the positive, but it is false, then he or she will be going for the different tests and identify and yes. But false negative is dangerous. So false negative is associated with the recall. So one of the metrics recall is more important here. Anyway, we'll not talk to their technical activities. Early detection of dementia. Have you heard any persons heard about dementia? Because you will be surprised to know, because of the lifestyle change and stress what we are getting because of the work culture, etc., we are getting extreme, we are working under extreme stress and we are undergoing extreme stress. You cannot believe Western countries like US and Europe, their stress life is very high. So psychological, psychiatric are very much demand in their countries because of the familial disturbance they are undergoing along with the work culture. So because of these things, this dementia and any neurological disease, they are becoming prominent in the day-to-day life. So is there any way we can predict the dementia? Before few years, it can predict the dementia and it will say that, but it is not for the universal things, it is for each individual. For example, I am going and I am talking to the doctor will say that yes, there is a high chance that you can after few years, you can toss through dementia area, work on these parameters. Control your sugar, do the regular exercise, reduce the stress, all these things. What a beautiful things. Converting doctor's unstructured note. Sometimes doctor deliver the lecture with an unstructured note. That can be converted and it can be